So I will have a quick opening for
Okay.
5 minutes, and
Sure.
I will pass the floor to you. Yeah. Thanks
Okay.
a lot.
Thank you. Thank you.
Okay. Good morning. Welcome to PyCon Hong Kong 2021. So I am Sammy, the conference chair of PyCon this year. So we will have a 2-day conference in starting from today and tomorrow. And the theme of this year is data science upholds the world. So you can check out our schedule and also sponsor information from our website, pycon.hk. And also you can post some sharing about the PyCon and Python as well to your social network with the hashtag PyConHK and PyConHK 2021. So this conference is organized by Hong Kong Python User Group, Open Source Hong Kong, and Hong Kong Creative Open Technology Association. Yes, also we are one of the official PyCon listed on pycon.org. And also, I would like to share about the statistics of the past PyCon Hong Kong. Yes, in average for the in-person conference is about 200 participants. And during the pandemic, we moved to virtual conference. So the number of participation is half of the average. And also you can find that in the in-person conference and also virtual conference is low difference for the number of sessions and speakers as well. So we have 1,000 followers on PyCon Hong Kong Facebook page, and 2,000 members on our Facebook group of Hong Kong Python User Group. And also we have more than 1,100 members on the Meetup group of Hong Kong Python User Group. And last year, some of our income is donated to Python Software Foundation. We donated that to $500 US in the name of PyCon Hong Kong to the PSF. So we will do it again this year. So some of our income in this conference is actually donated to PSF. So we also participate in PyCon APEC as a part of PyCon in the APEC region. So last year, Malaysia invited me to be one of panel speaker. And also this year is hosted by Thailand. And the next year, Taiwan is submitted their proposals to be the city host of the PyCon APEC 2022. So we wait for the good news from the PyCon APEC. So back to the conference this year in Hong Kong. So we will have an English chat starting from today, this morning, to the Saturday afternoon, and the keynote sessions will be the last session on the Saturday. And we also have a Cantonese chat tomorrow, and the half-day education chat in the next afternoon. So our keynote will be delivered by a new fellow member of Python Software Foundation. She is Hong Kongers, Chatting Ho, and her topic is from zero to hero, my Python journey. to the West. So we will have a three sponsor, PCCW, HKT, MySQL, and also Microsoft. So we also have some supporting organizations to help us to do some promotions to their members as well. So the next session will be delivered by Ryan Kwan. So he is from MySQL, and his topic is MySQL operator for Kubernetes. So I pass the forward to Ryan. So let me stop. Okay. So Ryan, can you try to share your slide? Okay.
All right. Thank you, Sammy. I can share my screen now. Okay, so good morning, everybody. My name is Ryan Kwan. I'm based out of Malaysia. So this is my second time presenting here. So thank you, Sammy, for giving us a chance to share our technology with the greater PyCon community. It's interesting that I only present in the Hong Kong conference, but not in Malaysia, my home country. Maybe I should get in touch with them. Okay, so the topic I want to share with you today is MySQL operator for Kubernetes. Why are we here? Is because this new MySQL operator for Kubernetes is written entirely in Python. And that's why we are very keen to share with you this very exciting technology coming out from our engineering team. Okay, next slide. Kubernetes, right, the hottest technology today. Everybody is, using, if not using, evaluating, going to deploy Kubernetes in the production. And if you're not doing anything on Kubernetes, I think you should, because virtually, most of the user, our customers, actively deploying, testing, evaluating Kubernetes for prime time production workload. Right, so Kubernetes is similar to virtualized infrastructure, right, like VMware, KVMs or Zen, but except it's a lot more flexible. It's the VMs or the container that is used is a lot smaller than the VMs in terms of the size, and it's a lot easier for you to package application in a open format, a standardized format. Such as Docker, in deploying application. So, of course, the Kubernetes platform cannot do all the infrastructure or the workload-related management stuff, and that's why there's this operator framework that people are using to create extension to Kubernetes to manage a specific workload or application they want. On the Kubernetes platform, right? So, so the objective or the goal of a Kubernetes operator is to help in deployment, right? Deploying application. For example, if you have a homegrown application that involve multiple components, you could create an operator, to manage that resources. With your own operator, right? So it also helps in configuring the applications, backup, restore, the common operation tasks that you will do on your application. Okay, so by the way, if you have any questions on what I'm presenting, I have a colleague who has joined in this session as well. So you can put your question in the chat, and my colleague Ivan Ma will help to answer. So before I dive into the MySQL operator, I want to just briefly explain what does an operator manage that we developed on Kubernetes. So the operator is developed specifically to manage the MySQL InnoDB cluster. So InnoDB cluster is a high availability solution that's part of the MySQL server. Right? So you can create a highly available InnoDB cluster for your production workload. So in this diagram, you are looking at a InnoDB cluster, which consists of 3 server. So this is the InnoDB cluster, which consists of 1, 2, and 3 server. And they form a cluster, and they synchronize data among the server via this framework called group application. Okay. And part of the InnoDB cluster architecture is this component called the MySQL router, which you can use to for your application to connect to the cluster. Okay, so and in terms of management, we have the MySQL shell, which support Python, for management, for creating the InnoDB clusters as well. So this is the InnoDB cluster that we have, and we have created a InnoDB. We created a operator on Kubernetes in order for you to deploy this architecture on Kubernetes, for your application, right? So with this operator, you can easily deploy a highly available cluster, MySQL cluster, on Kubernetes, for your microservices, for your DevOps, for your serverless application, and so on. Okay, so just a little bit more detail of what is a Kubernetes operator. So it's a software extension to Kubernetes to make use of custom resources. So in this case, we have a custom resource defined for InnoDB clusters. For example, in our architecture, we need a minimum of 3 MySQL server to create a cluster. And that would need to be defined in the custom resources. And think of Kubernetes operator like a human operator. So if you deploy a MySQL cluster to your infrastructure, you have operator to operate the InnoDB cluster. Right? For example, monitoring the health, taking backups, upgrading it, adding hard disks, and so on. So the goal of our operator is to achieve that, right? So it's like taking a human operator, package it as a Kubernetes operator in infrastructure to manage the cluster. Okay, so again, like the operator is written entirely in Python. I think the reason for that is because I think in our engineering team, we do have a lot of developers that's very familiar with Pythons, and hence the decision that we made on developing this operator using Python. Okay, so the same InnoDB cluster. So if you deploy it on Kubernetes, it will be packaged as a container on the Kubernetes infrastructure. So in this architecture, you will first have to deploy a Kubernetes operator, and then that can be managed using the kubectl admin CLI to manage the operator. And then you could use that to create the router as well as the InnoDB cluster. So it's native to Kubernetes. So you don't have to deploy the container, and then you need to use the MySQL admin utilities to manage, to configure the router. So all this, lower level MySQL administration task is hidden or is abstracted at the operator level. And we also have embedded knowledge in the operator to also manage the health, allows you to scale up, scale down the cluster. And that is all being done via the Kubernetes admin GUI. CLI. Okay, just to make a comparison of deploying MySQL HA on different platforms, right? So this is the more traditional way of deploying InnoDB clusters on a physical or virtual server. I'm just giving a very simple comparison in terms of the ease of setting up, ease of management, and on different platforms. Right, so it's easy to set up InnoDB cluster. Don't get me wrong, but comparing to if you are running this on a Kubernetes with MySQL operator, the setup, the management, it's a lot easier because that task of scaling, the command to scale the cluster is all embedded into the MySQL operator. Right? That helps the DBA in managing cluster, especially if you are using cluster for microservices. You have multiple of clusters, for many of your microservices. And of course, comparing to cloud, cloud is all managed, right? You just provision database and provision HA and you're done. I just use the database. So I would say, MySQL operator, it is your management if you are running Kubernetes comparing to VM or physical. So it's a pretty handy, when you are developing on Kubernetes. Okay, so let's talk more about what I'm supposed to share with you today, right? The MySQL operator for Kubernetes. Currently, this operator is in preview, right? So it's not ready for production yet. We do have a long-term goal of make it a lot more robust, a lot more functionality, a lot more a lot more operation tasks being embedded into the operator, right? So for the first beta, these are the functionality that you can expect from the operator, right? So it's the automated deployment of MySQL server as well as the MySQL router. It allows you to easily upgrade the clusters, manage the configuration, backup, and restore. Okay, let me stress again. You can test it, but I don't advise you to run it in your production because there's still a lot development going on. So I welcome your feedback if you are keen to test it. Let us know what functions, and if you encounter problem testing it, let us know. So these are the two servers that we support, right? The community, the free version, and also our commercial version with enterprise features. Right? So if you are using any one of this, they are supported with the current release of operator. And these are the Kubernetes platform that you can use for testing. And if you're using Kubernetes, I think these are you should be familiar with all this. Is very popular among the developers. For example, K3D, Minikube, and if you're on the cloud, well, for us, MySQL team, we use Oracle Cloud, and most of our testing is done on the container engine on Oracle Cloud. Okay. So in the cloud, but if you don't already sign up, we do offer trial account for you to try out Oracle Cloud, MySQL database service on the cloud. And part of the Oracle Cloud service is this container engine. So you can sign up the trial account and you'll be able to access the our Kubernetes engine. And once the trial has expired, you could still access some of those free resources. So if you don't already have one, I strongly encourage you to sign up on Oracle Cloud. Okay, so so much for the talking. Let me just show you how this works. Okay, so here you're looking at a sorry, just get this out. You're looking at the Oracle Cloud. What we're showing you here is our Kubernetes engine, right? So you can just create a clusters, and there's a wizard for you to that guide you. Well, actually, you'll create a cluster for you without you specifying too many resources and too many tasks to do in order to create a Kubernetes cluster in Oracle Cloud. So essentially, it will create all the virtual network. It would also provision, I believe, 3 nodes, for you to run your pods and container. So once it's set up, you can, just go to the Cloud Console and start using it. Oh, actually, Cloud Shell. So we have a Cloud Shell on the browser that allows you to, work with the Kubernetes quite easily. So once it's created, you'll see a pool is being created with 3 nodes, worker node. This is where you can deploy your application, your pod to the Kubernetes infrastructure. Okay, so that's the first part to get this done. And secondly, this is the website that you can download the preview version of our MySQL operator, right? So it's in the GitHub MySQL/MySQL-operator. I do have a demo to show you how to do this. In fact, it's quite simple. It's just a couple of YAML that you need to create. And then once the operator is created, you can start creating the MySQL cluster. Okay, let's go to the demo. Okay, so you're looking at the same Cloud Console again, but except this time, I'm going to show you how you can use the Cloud Shell to interact with the Kubernetes. Right, so and this service is free, and you can you'll be given 5 GB of disk space, and you could do all your development administration stuff here. So you look at the, so first of all, you need to get this set up so that you can use the Cloud Shell to interact with your Kubernetes. And this is just a first time setup. So once it's done, and the next time you come in, you don't have to do this again. Right? So it's basically just specifying the credential, which cluster you want to log in, what are the config, which region, and so on. Okay, so once that's done, then you can access the Kubernetes. You can now deploy the operator. Okay. So that's the GitHub page. What you do is to go here and then just copy that command. Right, essentially, it's a kubectl command to start creating those resources. So the first step is to create the custom resource definition. And second step is to deploy the operator, right? So there will be a namespace called MySQL operator created, and that operator will be deployed in that namespace. Right? So once you got that, you are good to go, right? So it's very simple to get this set up. So you have to give it a time of creating the container. And this is a very good, a very handy command called the -- watch for you to look at, monitoring the progress of creating the container as well as the different part. Right. So here you can see that the resource definition is created, right? So InnoDB cluster, and then you can look at the the part, and this is a watch command I just mentioned. So you can look at, so when you apply the YAML, right? So you have this progress going on, and then you can use this watch to see what, the progress of the creations of those part and container. Okay, so once that's done, now here comes the meat, right? So you've got all the operators set up, and you're now ready to use the operator to do something for you. Okay, so the operator will do this few things. First, it will create a MySQL server, the tree MySQL server, called the my cluster, right? So the name is called my cluster. And there will be a MySQL router, which you will use, which your application will use to connect to the MySQL InnoDB cluster. And a service called InnoDB cluster will be created. And also, in order to create the cluster, you need to first create a secret for the DBA of MySQL server. Right, so you have to create a secret, the username, and the password. So once it's done, then you can create the cluster. So the YAML file is here, right? So you can see it's very simple. If you have worked with deploying MySQL InnoDB clusters on Kubernetes without operator, it's a lot more things you need to do, right? And not just as simple as this. Okay, what kind of a resource I want to deploy? Like just InnoDB cluster. The name is my cluster, and the spec is 3 instances because the minimum is 3, and in term the router is 2 for HA purpose, right? And then the password. So it's very simple, right? Just 4 lines, and you get this whole infrastructure created for you. Okay, so let's look at how you can get that started. So looking at the time, maybe I'll just fast forward a bit. So essentially, the first part is just to set up the GitHub user ID, so that you have a credential that you can go into the GitHub to pull the MySQL container image. And this is the MySQL cluster YAML, a bit different from the one I shared with you earlier, with a few parameters, but it's similar. Okay, so you can customize it, but the basic, it's just 4 lines, right? 3 instances, the password, the router instance, and so on. So once you have that, and then you're ready, right, to run the command to get operator to create the InnoDB cluster for you. Okay, so you run the command, right? kubectl apply the YAML, and then you specify the namespace so that that cluster will be created in the namespace, so that later on, if you want to clean up, because this is for testing purpose only, so it's easy for you to clean up the resources once you're done with your testing. Okay, so you can see that there will be, so you will gradually create the tree server, right? And then once it's done, you can see that you have the 3 instances running, and so on. Okay, replica set is the class. It's the router. So there will be 2 router part being created, and then there will be a service, the MySQL cluster service being created, and with the list of ports that is being exposed, so that you can you can get application to use the MySQL cluster. So now we're just going to look at the progress of the creation, right? So -- watch. So you can see, the first, is the MySQL cluster -0 is created. Let me just fast forward. Yeah, there will be my cluster -1 and 2, 0, 1, and 2. And yep. And once you have all that running, and the process is done, right? And the rest, it's just to validate whether the cluster is being created properly. Okay, so let me just move on to the next. Okay, so here are some of the, once you get the cluster running, you could use kubectl to work with the cluster, right? So for example, you can look at the servers, look at the storage PVC, and to expose certain port of the cluster. And in terms of scaling, I have a short demo to show you. Hopefully I got some time to show you. So you can do edit, DB cluster, my cluster. This is the one that we created. And from 3 instance, if you want to scale it up to more, you can just change it to 5, and then the operator will then, instantiate the pod to 5 instances. So that's how easy it is for you to use the operator. Also, upgrades, without any downtime, it's just by changing the spec on the version that you want to upgrade to. Okay, so this is a long video. I'm not gonna show you all, but I want to show you how you can scale the number of server, from 3 to 5, right? So you do edit on the cluster, and you have to look at the instance. Here you see the instances. I'll change it from 3 to 5 and save it. And then the operator will then, change it and upgrade it or scale it to 5 instances. Okay, so you can see monitor, and then you'll see that the instance get upgraded or to get scaled up to 5 instances. So the value of MySQL operator, right, on the Kubernetes platform is that it gives you a database aware operation support, right, for your application, right? So with MySQL operator, it monitor the instance, it monitor the clusters. You can restart it if there's any problem with the cluster. Okay, so on top of what Kubernetes can offer, right, in terms of the application stability and high availability. Now, once you're done with the operator, you can use kubectl delete the resource and the cluster name, or in our demo, we are just deleting the namespace so that we can clean up all the resources. Now, in summary, if you are working in DevOps, microservices, cloud native, Kubernetes, I strongly encourage you, to try out our operator, because it's really simplifying, the MySQL operation deployment of clusters on Kubernetes. And do give us feedback, if you have, any good suggestion. I'm sure our engineering team will be, more than happy to, to listen from you. So with that, these are some of the links that may be useful for you to, follow us. So thank you. Hopefully I don't overrun so much. Hope you find this valuable, and hope to see you again. Thank you. Back to you, Sammy.
Thanks, Ryan. So, so I think we can have 1 to 2 short questions. So, if you would like to ask questions, you can raise your hand using the Zoom systems, or you can type your question on the chat. And if you ask questions, you will have an opportunity to win a prize. Yeah, we will select some winner from every day to get the prize from a sponsor. Yes, Joe, please. Yeah.
Joe, yes.
Yeah, Joe, you can unmute.
All right. Hello, Ryan and Ivan.
Yeah.
So actually, I've tried out the operators of other services like Postgres and Redis. So most of them would have a graphical user interface, which is embedded inside the operator service. So will it be in your plan to include GUI on this project?
Good question. So the GUI is part of the Kubernetes dashboard, or is a part of the operator?
Well, part of the operator.
Oh, okay.
Yeah.
I don't know whether there's a plan, but for the time being, yeah, it's using the kubectl. Yeah. But I'll certainly give this feedback to for our engineering team to consider.
Yeah, I like GUIs because actually the GUI doesn't do much, but it provides the essential information and actually generates the YAML templates that I really like to take a deep look on what I am really going to deploy into my cluster. So yeah, that would be helpful if the MySQL operator would provide this one too.
Okay. I mean, we don't have it now, but I'll feed it back to our engineering team. Thanks for your feedback.
Ryan, there are questions actually.
Yeah, I'm looking at it. Yeah.
I just answer one of those. Maybe you can, get another one.
Yeah. So I think you have answered Henry. There's Frederick Wong from changing replicas or config map. we can change the setting of typical MySQL deployment. What is the benefit from operator? So besides, the scale up and scale down, and there's also backup and restore. And I think over time, the goal of the operator is to make your MySQL operation a lot more smoother, by having those automation and monitoring, the health check functionality embedded into the operator. So yeah, so those are the things that we are all waiting anxiously to see in the next release. But for now, yeah, it allows you to deploy easily. It allows you to scale up, backup, restore, and upgrades. Hope that answered the question. Anything to add, Ivan?
Yeah, operators is giving us the handy way for like doing the container service. So so with all this like HA configuration, like what it is saying, replicas and config map. Okay, it is another different approach. So basically, operator from us, okay, we try to handle one of the deployment approach, which is what we call it InnoDB cluster. So there are many ways of doing HA configurations for MySQL. Replications, InnoDB cluster, or even some sort of storage level things. But what we do at this moment is more the #1 HA deployment approach, which out of the box MySQL is doing the InnoDB cluster. So you're referring some other so-called typical MySQL deployment, which was the old days configurations, but still workable today. So I hope that's actually operator is dealing with some more trendy way of HA deployment.
Yep.
Okay. Yeah. Thanks, Wang Quan, and also Afama to support these sessions. So thanks. Okay. So and also MySQL will have another sessions in Cantonese tomorrow by Afama. Yeah. So you can contact with them. Yeah. So thanks again. So next session will be shared by Alice Jen and also Ben Wong. Their topic is intelligent Python for an e-commerce platform. So,
hello.
Okay. Okay, you can share your screen. Yeah.
Okay. Hello. Hello, everyone. Can you hear me?
Yes, hello.
Hello, this is Ben.
Yeah.
And today, let me check this file. Okay. Okay, today I will share the topic of intelligent pricing engine. And actually, this intelligent pricing was worked in our cup shopping under HKT. And before that, I would like to let you know more about our team and all the business units under HKT. Actually, We are the big data team serve the analytics, data science, machine learning. This way. Project across the business unit, and actually we have a lot of business unit like as you know, the CSL 1010 Navigator, Now TV, and we have Dr. Cool, a lot of business unit, and we serve all the business unit for the machine learning AI project. And also we work closely with our internal business technology unit and engineering teams to develop the machine learning and AI projects. Okay, and before I introduce the intelligent pricing, let me tell more about the Cup Shopping. And Cup Shopping is an unified online shopping and reward platform of HKT since October 2020. It offers extensions of benefits to the Cup member to enjoy the convenient shopping experience with more reward. Anyone can earn the Cup loyalty points and the Cup loyalty points from subscribing HKT services, spend on any Cup business such as shopping, travel, insurance, or spend on the Cup products as well. You can use the loyalty points to pay less for shopping, and after shopping, you can earn more and spend them in the next time. And actually, we have over 3.2 million Cup members nowadays, and over 1 million unique visitors come to our app or website every month. Cup shopping always bring a lot of well-known brands and partners across multi-category. Recently, Donkey was soft launched at Cup Shopping, and we have a piece order of iPhone 13. However, Cup Shopping is facing very competitive e-commerce market in Hong Kong. On the one hand, it is over thousands of products in Cup Shopping platform, and competitors always change the selling price for every single product on every single day. On the other hand, the market price is very transparent, and customer it's very easy to search and compare the price online. How to optimize the marketing effectiveness by stating the competitive in the market is always our challenge. The traditional approach is to collect market information manually and then compare with the existing product manually, item by item, one by one. This approach is very time consuming and less cost effective. Therefore, Cup Shopping has an urgency to build an intelligence to search and compare the price in the market, and then we add to the market quickly. Improved customer experience is also very important to the e-commerce. And we are now still working in the personalized pricing and offer, but not yet completed. Okay, overall speaking, the intelligent pricing engine is a competitor-based analytic to create price competitive edge over rival. There's a three major parts in this engine. The first part is to acquire market information by web scraping. Web scraping is very essential at least to get external website information. There's many useful attributes can be extracted. After scraping the relevant information from different competitor websites, the next step is to match those data with our Cup Shopping information. The data consolidation and integration are critical procedures, and I will show you more how it works in our cases. After putting the data together, we can build the price recommendations and provide personalized experience to the customer. And for the web scraping here, I try to point out some critical decision and how you decide what kind of information to be extracted from competitors' website. And please bear in mind that this is a regular job. Try the best to minimize the load on the website. Otherwise, you will be blocked by the competitors. Generally speaking, there's two types of product information can be scrapped: the product listing page and product detail page. Product listing page lists many product information in one pages with the key information only, such as the product title, price, or one picture. The product detail page contains much information such as product description, product features, several pictures, product rating, etc. At the same time, it generates very huge data loading. So before you decide to scrap the information, you need to think about how many information you need to scrap and to balance with how many data you will generate to trigger the loading. Okay, secondly, please remember to use the randomize or rotate the user agents and IP regularly. And actually, we outsource this part. And lastly, remember to scrap the data during the off-peak hours. Okay, and now is the concept of combining the text and image similarity to match the product information together with different websites. I suppose we scrap the product title, brand, picture only for the competitor websites. However, there's no unique key to join those competitor informations with our existing product information. To do so, first of all, we need to apply different techniques to match the product indirectly. First of all, we create the brand matching across website. For example, a website A called an Apple Inc. and the website B called it Apple. We cannot match it directly, but we have to build a brand matching across the website. The purpose of putting the brand mapping in the first step is mainly due to the combination of matching we want to reduce. For example, I assume that both website A and B have 300,000 products on shelf. Without the brand matching, we have to handle 300 billion combinations for the test mining, the test and image similarity analysis. It's very huge volume of data, and it's wasting a lot of time to do the combination of the similarity analysis. But if we do the brand matching first, then we can associate the group, we can narrow down the matching combination significantly. And brand matching is also help us to improve the matching accuracy significantly. Then we use the regular expressions to identify the model number for the product title. And in real situation, not all products have the product number, but once it exists, it becomes an exact match with 100% accuracy. For those products without model number, we will use cosine similarity to break down the wording by letters for comparisons. Some test similarity score will then generate to quantify the similarity level of those words. Here is an example of Vision Kids instant camera in different websites. We can match the brand, but the model number is not available. Instant camera is the only words for this matching. And actually, this kind of matching may not have a very high accuracy. And then, of course, we are looking for further improvement of the accuracy. Therefore, we are looking for the image comparisons. And there, okay, and there some image comparison tools in the market, such as the Google Vision API, were available for the matching. And actually, I applied it to generate another score. I call it image similarity score. And here is an example for the Vision Kids camera. Actually, based on the cosine similarity, we have only 0.45 test similarity score. But based on the image comparison, we have almost reached 100% accurate by comparative image. And the image similarity score help us to improve the significance, from those products with limited information. The product with higher similarity score will then link together for price comparison and ultimately formulate our pricing strategy. Right now, all analytic data are ready. The next step is the last step actually. This is the last step is to create different personalized experience. As you know, some people always search for the information and price through the Google search. For those customers who are more price sensitive, they will always find our most price competitive products ranked higher in the Google Shopper. For anyone who are new to the online shopping, we make them easier to find us in the Google search and to create some positive customer perception to us. Because the customer always find our product competitive than the competitors. From the marketing team's point of view, the marketing is more easy to allocate the medium spend on those products which is more competitive. On the other hand, in our website and app, if some people are bargain hunters customer who are looking for a great discount product, our website will recommend most price competitive products across their shopping behavior and preference. From our merchants or brand owner point of view, we can help them to personalize the offer and discount according to their customer point of view, according to the customer behavior. Yeah. Hello. Yes, and then we have a lot of hiring. Yeah.
Thank you, Ben. I'll cover from here. So as you can see, across the PCCW HKT families, we have financial services, payment, health, well-being, education. So shopping, travel, some of financial services as well. So we are looking for a lot of talents in the tech stack, MarTech, retail tech, MedTech, insure tech, in all those following areas. Very specifically, we're looking at people's skill set with Hadoop, data stage, on cloud platforms, AWS, Azure, GCP, in terms of programming, Python, R, SQL, machine learning, deep learning skill sets, specifically on NLP, computer vision, neural network, and also we call hyper personalization. The topic that Ben mentioned earlier, if you recall, we have the intelligent pricing model. In addition to attracting customers when they search for some merchandise, what we really want is to be able to, once they land to our shopping site, we'll be able to provide them with a more personalized pricing offering, which is tailored to customer needs and wants. So we need a lot of people. You can send your CV to the email at career-tag@pccw.com. If you're interested, if you have any one of the skills about, send to us. What I really also want to share with you, Ben, can you move to the next slide, is in addition to tech stack build, you can also come to our PCCW HKT career portal, where we have a list of jobs available. You can get more details. You can also apply online. You can look at the the QR code on the right corner of the screen, which will tell you which will take you immediately to the the job site that we have all the listed information. Okay, next one. So this is just some examples. In addition to our PCCW HKT companies, we also have a very nice startup ecosystem. We work with like companies like Assess Time, Sophie, fintech sector, to basically using a combination of API and also the data that we have to provide better services to our customers. So you joining HKT and PCCW, we're not a 40, 50-year-old company. We're actually as young as startups as well. All right, this concludes our presentation. Again, you can use the chat to ask us any questions. I think, as we said earlier, well, you have a chance to win some prize at the end of the day when you ask questions. So feel free.
Thanks, Ben and Alice. So this Q&A time. Yeah. So any questions to Alice and Ben? So you can raise your hand or put your questions on the chat. Yeah, and also if you ask questions, so you will get an opportunity to get a prize from the PCC.HKT. Yeah. So I saw questions coming from the chat.
Yep.
So Liu asked that, hey Alice, where does product manager fit into your company's goal?
I'm sorry, can you repeat the question again?
Where does product managers fit into your company's growth?
Oh, product managers play a very important role in terms of our product development, specifically in the analytics product development area. We typically work side by side with our product managers in terms of developing new analytics data products. For example, we're looking at like retail solutions using our data. So we've got we call like a digital product team, and also our platform team, which is more from supporting from IT side, and we're the analytics and the analytics team. So three of us, we actually work very closely together in terms of develop a prototype of a product, and find, let's say, potential customers, test drive the product in the market before we actually do a full product launch. So product managers plays very important role in our organization. We have them in the some are sitting in the marketing area, some actually are sitting very close in the analytics team as well.
Thanks, Alex. Yeah. So another question is, SE is really easy to get items shipped from overseas when doing price comparison. Do you look into shopping website of other countries?
Ben, I leave that to you.
Yeah.
I think it's Ben questions.
Yeah. Yes, there's a lot of it. Nowadays, the online is very transparent, and people can get the price or to get the purchase anywhere. But we need to focus on because web scraping is also like cost it's very time consuming and with a high cost. So we need to fully understand your target customer. What is your target customer, and what is how they purchase in the online. And actually we will do some analysis to understand their purchase behavior and target those who are our major competitors. And right now our major competitor is still in the local market, a lot of overseas. But of course, if the environment change, then we have to scrap overseas as well. And I would say that it's not just scrap everything from the website. You need to fully understand your target customer behavior, and according to the change of their behavior, you need to change your strategy and your methodologies as well.
So in other words, we don't compete just price alone. I think the price is a really good like a starting point for us. I think we want to stay competitive. What we really want to do is we want to provide a better we call personalized product offer and services, and also with our unique retail shop support. We're able to provide our customers, not just in terms of just purely from a price perspective, but we also support them with identifying the time and they need the time that when they need a product, and then also able to give them a more personalized, be it a product or service recommendation. So it's the relevance. It's not just the pricing. It's also the relevancy and the customer experience that also matter a lot to us.
Yeah, thanks, Alex and Ben. And also another question is how are text and image similarity scores combined? This is a question from VC. Yeah.
Actually, there's no a standard rules how you combine the score. And actually, we did some analysis the sample to come to see how it combine the score to get the highest the highest accuracy against the result. And then we generate the rule, the combination. Actually is maybe half or for example, but we did some analysis on that, but it's not a standard machine learning or a modeling technique on that part. Yeah.
Thanks, Ben. Yeah, so I'm checking other questions as well. Yeah, yes, some question on the chat. Yeah.
Yeah, I noticed there's a question if user clear their cookies without able to do personalization. One of the thing you're right, and then one thing that we actually encourage our members to log in. So once you log in, we actually will be able to identify you're the club member. You'll be able to get a better services, more personalized recommendation. So that's one area we try to improve upon. Encourage customers to log in, when they land to our site or register. Even registration is like a very simple 10-second process.
Yeah. So another question from SUTL. Hello, Ben. As you mentioned earlier, web scraping is a regular job. What strategy should be taken to avoid being botted? Yeah. So this is the first part of his questions. Yeah. Ben,
yes. Actually, we try to estimate the first of all, you need to test the loading, and then how many data you are going to extract from that website first, and then you need to first of all define how what kind of information to be critical for the download. First of all, you need to define the information you are going to extract, and I assume that it's all come from the product listing page first, and then you need to calculate how many pages, how many data to be downloaded, and then you will split the extraction the extraction by different time slot in the off-peak hour to avoid being detected by the competitors. And actually, for up to now, we haven't been blocked by the competitor.
Please don't tell anyone.
Yeah, please don't tell anyone. Yeah, otherwise we will suffer. But and we are very we try to control our data expression. Yeah, and to avoid that. Yeah, I haven't got any strategy or to avoid that, because actually different websites have different behavior. You need to test for the small data first, and once it's okay, you try to increase it gradually until you can scrap all the information, and then you need to work out how to extract the data regularly. Please don't do it every day. You need to have some importance. For example, some product with a high moving the price with more dynamic, or those product is your business focus, then you can increase the frequency of extract those information. But for those information which is not really relevant to your business, then you can, even though not to extract them.
Thanks, Ben. So I think the last question is also from SUTL, and the second part of question is also some shopping site show both original and discounted price for a limited time, like Golden Week special offer. How is it being handled by your team?
Actually, I will handle it. As Alex said, we are not only just focused on the competitive price, but we still if the competitor have a very discount offer, I will not undercut to compete with them. So and we will just focus on those product we are focused on, and also we will focus on the product that the price is for the long term, but not for the once-off campaign and or event. This is our strategy.
So I think we can have one more questions from Kelvin Lee. So he asked that do you only use Python to perform the web scraping? If so, which library package modules do you use to help you with the web scraping?
Actually, I as I know, we use the iPhone for the web scraping, but the detail actually is done by my technical team. I haven't got the information yet on hand that what kind of the library, but as I know, this is quite easy to find, but the scraping, the content of the scraping is tailor-made by each different website. So we use the Python, but we build our own program. We build our own Python.
Thanks, thanks Ben to answer question, and also Alex as well. Yeah. So for those who asked the question on the chat, so you may update your so you can send me your registration's name so I can mark it down. Yeah. So I saw some of you already sent your registration's name. Yeah. So so thanks again, thanks Ben and Alice to share with us.
Thank you.
Thank you.
Yeah.
Pleasure to be here. Thank you.
Yeah. So we will have a lunch break from now, and we will have the another sessions starting from 2 p.m. Yeah. So the next session starting from 2 p.m. will be delivered by Barry Tam. The topic is applying ML modules to cooling load predictions for high-tech energy effective in the buildings case study. Yeah, so it's about the building service engineer. Yeah. So we will see you again at 2. Hi everyone. So we will start the afternoon sessions of English chat of PyCon Hong Kong 2021. So the next sessions will be delivered by Barry Tam. His topic is applying ML machine learning models to cooling low predictions for higher energy efficiencies in buildings, a case study. So I pass the floor to Barry.
Hello, can you hear me?
Okay, Barry, you can share your slide. Yeah.
Okay, sure. So can you see my screen? Yes.
Yes.
Can you see the full screen, right?
Yep.
Okay. Yeah. So if things all right, I can start now, right?
Yes. Yeah, you can start now. Thanks.
Okay. Yeah. Thank you for inviting me to give the talk today. And on behalf of ETEL, I'm going to present you the topic of applying ML models to cooling load prediction for higher energy efficiency with a case study. So my name is Ben Tam, and I work as a R&D engineer at ETEL Building Services Engineering Limited. And I obtained the bachelor and MPhil degree in physics. Maybe there's some technical problem. Can you see me switching the slides? Yeah.
Yes, we can see that you
Yeah.
switch the slide.
Yeah, sorry about that. So and I currently work on 3 projects. Just let me get at least one first. Yeah, here it is. I'm working on like chiller plant optimization and automated fault detection and diagnosis, AFDD, both of which are related to central air conditioning system. And I also work on data pipeline. And so today's rundown will be divided into 4 parts. First of all, I will give you a short introduction of central air conditioning system, and you will understand the basic component of a central AC system. And most importantly, you will know what is cooling load. And then we'll go to the second part to discuss why do we need cooling load predictions. And the third part, we will discuss our ML models. Finally, we will summarize our findings. So let's begin by understanding what is a central AC system. So in a central air conditioning system, you have something called chillers. So chillers are the equipment that responsible to cool down the whole building. So how does it work? Well, actually, there are water pipes passing through the chillers, and the chillers does their hard work to cool down the water, say down to 7 degrees Celsius. And this water will be pumped to different floors, represented by this rectangle here. And in each floor, you will have something called air handling units, air chillers. So just think of it as a fan. So you have cold water comes in, so cool down the air, and you switch on the fan, and therefore you have the cold air provided to the office, to your indoor space. And so that's basically air conditioning. And what's in return, the indoor heat is being absorbed by the cold water or chilled water. Say the temperature increased to 12 degrees Celsius. So this water goes back to the chillers, forming the closed loop water cycle. So basically, this part is the major component of the central air conditioning system. And of course, the chillers does a hard work, they generate loss of heat. They will be carried away by other equipment like cooling tower. But that's not the focus of today, so we just put it here for your interest. So if you think of the central air conditioning system in a higher level perspective, what it does is very, very much simple. So you provide electricity to the system, switch on the equipment. Then what it does is simply extracting the heat away from the indoor space and dump the heat to the surroundings. And so here I would like to introduce a keyword for you. that is the cooling load, which is the heat extraction rate. So by now, I hope that everyone would understand what is cooling load. It's simply the heat extraction rate from the indoor space. So then we go to the second part to discuss why do we need cooling load predictions. So we start by thinking a daily routine of an operator or a BMS or just a traditional program. And assuming that we have two chillers here, one have a larger cooling load capacity, one has a smaller one. So let's say the time now is 6 a.m. and you have to pre-cool the indoor space for the office hour, for example, 9 a.m. also. So which chillers should the operator or the BMS program to switch on for the office hours? That's the question he or she need to ask. And maybe he feels like today is hot or something. The cooling load may be large, like 1,500 kilowatts. So if you look at the figures on the right-hand side here, you have to switch on chiller 1 because chiller 2 failed to provide such a high cooling load. So let's switch on chiller 1 and see what happens. And the green lines are the actual cooling load being measured for the office hour is actually much lower than the operator expectation. So what's the consequence? Well, if we do some simple math here, let's say, assuming we have a chiller 1 operating at this cooling load, 1,200 kilowatts, then we obtain a rather naive model will obtain the 252 kilowatt power consumption for chiller. So, well, that's normal, right? So, but if we switch on chiller 2, what happens is that we actually obtain a much lower power consumption, just 184 kilowatts. So that means if you fail to predict the cooling load in certain accuracy, you switch on the wrong equipment, wrong chiller type, then you are generating the energy wasting control. And maybe some of you will complain, why do you assume this is a linear model? Well, this is just for illustrative purpose. In reality, we know that chiller power actually depends on other parameters here, like water temperature and flow rate and so on. So just for illustration purpose here, we demonstrate that the importance of cooling load predictions. So if we fail to predict cooling load accurately, we will switch on the incorrect chiller and generating and waste the energy. So if you still think it's a little bit complicated, let's do an analogy here. So let's assume cooling load is just a bunch of people here, and chiller is the vehicle type. So what is our task here is like predicting the number of people, and then we have to switch on or call a suitable type of vehicle to carry the people to certain destination. Let's say you predict that a bunch of people need to be carried to a certain destination. So what will you do? You call a tourist bus to carry like 10 or 20 people to some of the locations. But unfortunately, in reality, only few people shows up. Well, the tourist bus, of course, can still carry these people away, but what you are doing here is actually inefficient. What you should do, maybe you just call a smaller taxi, or in our case, in the cooling load prediction, just switch on a smaller chiller type. So by now, I hope that everyone would understand the importance of cooling load predictions. And then we will go to our main topic to discuss our cooling load prediction model. So let's first define our problem here. Our problem is to predict cooling load, say 9 a.m. to 10 a.m. and predicting the early morning, say 6 a.m. or 7 a.m. And we actually build the cooling load prediction models for grade A office buildings in Hong Kong. So how do we build our models? Well, we actually use several Python tools, such as Pandas, Seaborn for data visualization. And of course, the most important one is the scikit-learn to actually build a model. So typically, how do we build a model? Basically, just these 4 guys here. We curate the data, we clean it, we do some feature engineering, and then we build a model. So this is just a typical flow. But what I would like to emphasize is that data cleansing in our case is a little bit special. Most of us will just remove the missing data. If you're familiar with Pandas, that's just calling a drop NA method. And also remove some outliers noise, perhaps applying a moving average. And we also need to filtering out some non-stationary time series, because some of the equipment would behave having a transient dynamics. So those data are not representative, so we have to remove them. And we also have to correct something called sensor bias, because building data are not so accurate. So if we do not neglect these kind of bias or errors, those errors will propagate in our computation and our models would not be correct. We had a chance to publish the paper to Energy and Building, applying Bayesian method to find out the sensor bias. So if you're interested, you can refer to this link here. So let's begin by model version 1. So in model version 1, we decision trees ensembling together, each make its own prediction, and then we aggregate them to generate a final random forest, a final outcome here. That is our cooling law. So the first model, we have several features input for our model. That is the difference. We also have weather data. So we put it in, you feed it a few years ago. That's our result. What you're seeing here is the predicted cooling load by the model against the actual one. And the scatter point is square error with these values here. So if we put it into actual production environment and we run it, for example, in 2021, we obtain these figures here. So the bottom panel is the outdoor temperatures. You see there's a profile here. And on the top panel is a little bit difficult to read. I will guide you through. You have the blue lines here. This is the actual cooling loads. And the orange lines here is the predicted cooling load by model version 1. So it's mimicking the shape here, right? So if you also see some of the sometimes the cooling load is very low because those days are holidays. So our model captures it. But and you also see some kind of colored bars here, right? So what does that mean? If you would like to operate your system in certain cooling load range, say for example here, like the orange range, like 500 kilowatt to 750 kilowatts, what you will switch on is one large chiller. And if you would like to operate your system in this green range, you will switch on one large and one small chiller. So what I would like to highlight here, as the title suggests, the P4, what is the problem, is that in this range, our model prediction is consistently greater than the actual ones. So why is that? Because if you look at the temperature here, there is a drop starting from 22 date, but it fails to adapt the change for the weather conditions. So it's sort of like mimicking the last week cooling load profile. So we overestimate our cooling load, and that would be energy inefficient. So why is that? If you look at the feature importance of the model version 1 here, what you are seeing is that the greater the value, the percentage here, the more weight the model will put onto that features. So most of the time, the feature will learn whether it's Sunday or holiday. But the second greatest part is the cooling load profile. It's learning the historical cooling load profile. And the final one is the weather. So we suspect maybe our model is learning too much from the historical cooling load. So we have to revise our features for our model. So let's go to the model version 2 here. So we do not change our ML algorithm, same random forest, but we have to completely remove our cooling load profile because maybe we think it is learning too much from it. And I will guide you through the rest of the features here. So the first one is the Sunday or public holiday, which also present in the model version 1, but I would like to give you a concrete example why it is a good feature. So what you are looking here is the cooling load against the outdoor air temperature. And you already see it is separated into two groups, depending on whether it's Sunday or holiday or whether it is a normal working days. So for the normal working days here, the cooling load actually increases with the outdoor air temperature. So pretty obvious because the hotter the day, you need more cooling load to extract the heat from the office. So for the non-working day, the cooling load is low and it's not quite depends on temperature. So from these figures alone, you already see these guys here is a good features. And just a remark, so how do we know whether the certain day is Hong Kong holiday or not? We actually adopt a Python package called Recommender. So if we focus more on the working day cooling load profiles here, you actually see quite a lot of vertical strips here. Even at fixed temperatures, outdoor temperatures, the cooling load varies a lot, right? For example, like 1,000 to 1,400 kilovolts. So the question remains is, what are the features contributing to such variations? So how do we do it? We actually fit these figures here using something called isotonic regressions, minus it by the actual cooling load, we obtain the residual. And residual is something that is not explained by the temperature. And we have to find out what other features contribute to such the residuals. And just a little bit details of what is isotonic regression is also provided by scikit-learn. You can go through it if you are interested. So the next slide here, we are showing the cooling load residual against the month here. What you are seeing is that this is a box plot here, in case you are not familiar with it. Box plot is visualizing the percentile of the data. So what I would like to draw your attention is the Q2, the median, the 50th percentile. What you can see that even though after we deduct the temperature contributions to the cooling load, we still see some modulations for different months. So this, from the data alone, we think that it maybe is a good feature for our model. And then we go to other part, that is the cooling load against the date of week. What we also see the median is also different for different weekday. For example, Monday has a larger median and Saturday has a lowest median. And finally, we also find something interesting here is that if this is a working day and it is after holiday, the cooling load is just slightly bit greater than the normal working days. So why is that? We provide an interpretation here. So in a holiday, you have cooling load, but it's very small from the previous slides you already know. But you still have some heat absorption from the surroundings, like the sun, the other external factors, external environments. So you obtain an inequality here. Your heat absorption is greater than the cooling load. So your office temperature would rise. And therefore, you require more cooling load after the holidays. So we think that this is also a good kind of good feature, although the median difference is not quite large. So we put all these things in, the temperature and the days related features to our random forest and train it. So we apply the train test split from the scikit-learn to split our training set and test set with 30% test set. Then we train our model with something called hyperparameter search. You see here, we instantiate our random forest regressor and we put it in a grid search series, which is to perform some hyperparameter search. And then we also adopt the K-fold, which is used to split the training set and cross-validation set for training our model. And then we apply the dot fit to actually fit our random forest model. So we fit it, and that's the result here. You see that most of the feature importance, that is the most important part, is the outdoor temperatures as expected, and the rest of that is days-related features. So let's compare the model version 2 with model version 1. What you are looking at is, again, the predicted cooling load against the actual one. The points also scatter around y equals x. But what I would like to draw your attention is the root mean square error here. In fact, the model version 2 on average is a little bit less accurate than the model version 1, even whether it is training set or a test set. But our title suggests still kind of preferable. Why is that? Now let's look back at the same figures here. Again, it's the June 2021. Blue line is the actual cooling load. Orange line is the predicted cooling load by model version 2. What I would like to highlight here is that in this part, you're seeing that the outdoor air temperature drops, and our model, the orange line, is able to capture such a change. And what you can see is that the predicted cooling load and the actual cooling load falls into the similar region, operating at the same chiller pattern. So our model version 2, even though it's on average is less accurate, but it is able to adapt to certain change in weather condition. So of course, we build a model that's POC. We have to deploy it to production environment. We actually apply these tools here. We have the advanced Python scheduler to schedule our job. We have Flask, and we also use some containerization technique, Docker and Kubernetes. And so this is just cooling load prediction, but how's our client benefits from our solutions? And in fact, cooling load prediction is just the one part of the whole solution. Cooling load prediction provide the values of cooling load, of course. And then we also have this guy here, that is the optimization. What it actually does a lot of hard work here to recommend the actual control to the BMS servers. That is you think of it as a server from the building. So for example, it will recommend which chillers to switch on. And of course, we also collect some of the real-time data to do the optimizations here. So what our clients can benefit is that with cooling load prediction, we are able to have a more energy efficient for the morning start up to pre-cool the office. And for the optimization part, we are able to recommend an energy saving control to the server. And at the same time, we have to maintain the chiller plant stability. So I will summarize the findings here. So the benefits for the clients, and of course we just highlight, is that our cooling load predictions make morning startup, that is to pre-cool the office, more energy efficient. And we just like to highlight some practical work on some ML models. So in fact, both accuracy and robustness are critical in commercial solution. You see model version 1 is accurate and model version 2 on average, but it fails to adapt a change in the weather conditions. So both accuracy and robustness are important. And second is about something called feature engineering. And feature availability is very important because you do a POC, you find the feature is good, but in production environment, those features might not available. So your model may not be able to put it into production. So we'd like to highlight these key points here. So when building a model, think about the production environment, whether those features inputs are available. And finally, we'd like to address the point about data cleansing. And because data are not so accurate in BMS or IoT data, especially sensor bias, we have something called sensor bias. So more on data cleansing is more important to just simply dig down to some of the advanced ML models. So basically, this is the talk for today. If you have any question, I will be very welcome to answer.
Thanks, Barry. So if you have any questions to Barry, so please raise your hands now. Or you can also type on the chat as well. So we will looking for any questions. Yeah. Okay, as I found one question on chat from John. So do you control the chillers for data center or telecom exchange?
By control, I think we are actually kind of like recommending the controls to the BMS, I mean to the client, so that they would know which chiller should switch on or switch off. And we actually have some sites, most of which are commercial buildings. Also, some of them are data centers.
So
and I also,
yeah. So Chris also asked, only use RMSE to weigh your model performance.
well, actually, we this just show one of the metrics using our MSE, but of course, we previously also emphasized the importance, like whether the predicted cooling load and the actual cooling load falls into the same region of cheetah pattern operation. We also use that metrics, that is whether the cooling load falls into the same cheetah pattern operation for as our metrics. So we also apply having other measures to cater to measure our performance. So just showing our MSE here.
Thanks, David. So any other questions? Yeah. Are there questions coming from VC? As mentioned, that sensors data is biased and even unreliable. How may such case be discovered and tackled? Yeah.
Oh, well, actually, we are actually adopting something called Bayesian method to find out whether the sensor bias is very critical or not. And then we do some data cleansing on our data and finally build a model. So actually we apply some of course, we do some extra data analysis, the EDA first, and then we apply something called Bayesian method to find out the sensor bias.
Yeah. Thanks. So next questions from Christine Chen. Does it support all BMS bands?
Okay. Okay, so this is about kind of like integration work from software to the actual BMS program. So our surface is kind of like independent of the BMS brand. We actually deploy our surfaces to our servers on site, and then we actually do some integration work with the actual BMS program. So it's what should I say? It's independent of the BMS brands, our solutions. Yeah.
So a question from Tommy Cock, just for interest, does regional winds be considered as a feature, as it may also affect the head transforming?
Well, yes, there's many kind of like weather conditions that contributing to our prediction model, but I would like to highlight is that again, that is the availability of the features. So most of the time, not all the features are available in the production environment. So have to think about these concerns when building the model. So that's why we didn't put most of the like winds or solar radiation to our production model. Yeah.
So we have 2 minutes left for each sessions. Yeah. So am I find at least 2 to 3 more question or message on the chat. So so bear with. Do you have any question you would like to answer on the chat? Yeah. You can select 1 or 2 from the chat. Yeah.
Okay, let me see. Okay, so LL does it considering the aging of equipment to make recommendation? Yes, that's actually a very good question. We actually do lots of hard work to find out whether the data are representative. And what you are mentioning is like the cheetahs or bumps are deteriorating. And we actually have some platform called FDD, fault detection and diagnosis, to find out whether the equipment are actually aging. And about your questions is whether we put it in to make our recommendations, we would sort of like retrain our model if we discover that the the equipment is actually aging, we retrain some of the model, not critical precision model, but some other models, and then we put it into to capture the reality of the chia plants. Yeah.
Okay. Yeah. So thanks. Yeah. So
yeah.
do you have any? Yeah. So do you have any follow-ups on the message on the chat? Yeah.
Yes, Chris mentioned that why Model D is better than even if the RMC is higher than model version 1. If you remember that, so model version 1 uses a features called historical Guadagno profile, which of course is mimicking the same, let's say the last week Guadagno profile. Of course, when the next week, if everything's all right, so the prediction will be very good. But when the weather changes, let's say from 30 degrees Celsius to, let's say, down to 25 degrees Celsius, then the model fails to predict that special event on that date, and it is sort of like commercially not quite acceptable. So RMSE is just, I would like to demonstrate that this is just as most of us would use these metrics to define whether a model is good or not, but in production environment or in commercial solutions, this is not the only criteria.
Okay. So thanks for Barry to give up a presentation today. Yeah. So we appreciate for that. So with you have so with the participants have any follow-up questions, you can contact with Barry. Yeah. So thanks again, Barry. Yeah.
Thank you.
So for the participants who asked a question, so maybe some of you doesn't use the registrations name just like Chris, LL. So it would be great if you can send me your registration name. So then you will have an opportunity to win a prize from our sponsors. Yeah. And then the VC, yeah. Okay, so it's been sharing, and okay. So the next session will be start from 2:45 by Kim Philo.
Hello.
Kim Philo.
Hello.
Nice to meet you.
Hello. Nice to meet you. Yeah.
Yeah, it's great that you share with us again.
Yeah. Because last year I joined PyCon Hong Kong 2 times. Yeah.
Yeah.
I try to share my screen. Yeah. Okay. Can you see my screen now?
Yes.
Hi to the video view. Yeah. Sammy 嗰個聲得唔得？Hello，
OK，
啊，OK 啊，嗯，因為今日喺廣州個 office 嗰度，所以可能會好啲，嗯。
So we are going to start the next sessions. The next sessions will be delivered by Kim Phil Low. He will share about how Azure machine learning and cognitive service can make your life easier. So I pass the floor to Kim Phil.
Okay. Hello, everyone. Hello, organized. I'm very happy to join PyCon Hong Kong because I joined PyCon Hong Kong last year 2 times, and this time is 3 times. I love Hong Kong, and I think last year I am Microsoft MVP. Now I join Microsoft. I'm Microsoft card at the OK. So I think I will give you a very interesting topic this time. This topic is how Azure machine learning and cognitive service can make your life easier. The first thing is, if you want to download today's event resource, you can scan this QR code, and use browser to access this link. Yes, of course you can follow our YouTube and Facebook and LinkedIn. My name is Kim Phil. Microsoft Cloud at the OK. Former Microsoft MVP and Xamarin MVP and Microsoft RD. If you want to know something about me or something about some technology about artificial intelligence and mobile application and cloud at the native, you can follow my GitHub. And so I have one very good deep learning project in open source. This is TensorFlow.net. I think I focus Python, but I love .NET too. So I built a TensorFlow.net, can let more .NET to use deep learning and using C# language. You can follow this open source. And if you have any question, you can email me, kimvelo at microsoft.com, and focus my blog that to Kimvei. My Twitter is LJH A304. Let's begin our session. Hello. The problem with AI, I think many people.
Sorry to interrupt you. Kim Phil. Are you sharing your slide
now?
No.
Oh, I forget to share my screen. Yes. Oh, sorry. Okay.
So I just checking whether is another screen.
Okay. No, sorry. Okay.
It's okay. Okay, go ahead.
Oh, okay. Sorry, everyone. I think we can. If you want to scan get the event resource, you can scan this QR code and access this link. In the browser, and follow our Microsoft Hong Kong on YouTube, Facebook, and LinkedIn. Of course, I tell you about that. GitHub open source project and email and blog. You can find me. If you have any question, you can send email. If you want to learn more technology, you can follow my GitHub or my dev.to or blog. Okay, let's begin to our session. The problem with AI. I think many people love AI because AI means artificial intelligence, but people say intelligence is important. I think artificial is important too, because some data is the big problem. Many people say data focus intelligence, but forget that you need to get data and some prepare some data and repair some data. So this is problem, and there is a huge demand to use AI and computer vision to solve business scenarios. AI technology is new and incredible complex. I think, and if you join this session, you always use AI or want to know how to use AI. So I think AI technology is very important now. But expert talent is the primary limitation. Just like that, if you want to finish some AI project, you need to more all technology, just like you need to know Python, and you need to know some machine learning, you need to know some deep learning problem technology. So I think if you want to be data science or some AI expert, you need to do more jobs and learn more technology. And another thing is a solution. Now in the new normal, I think AI is very important too. It can help you to some your company and some startup company to finish some jobs and some different scenario and some industry scenario. Also, I think if you want to know AI, you need to do more jobs. But this session, I can give you all selection choice, different choice to finish AI project. Okay, let me go back to machine learning. Machine learning, and this is all PyCon about machine learning. Just like you need to prepare data, build model, and train model. Of course, after that, you need to manage your model and build image to save model and deploy to the public cloud. Oh yeah, as service. So I think each step is very important. Just like that, the first step is prepare data. Just I say, data is important. If you have no data, you cannot build or machine learning or artificial intelligence. So I think machine learning, you need to finish. You need to have a big data about that. And another thing is train. Different train method. You can use deep learning framework. You can use machine learning framework to finish that. But training is a consumer all your times, because you need to wait the result. If you have many data, you need to have many times. Just like that, I have one GPU and I want to finish some data analyze or some training. I need to 8 hours. This is my job time. Yeah. Another thing is deploy to the public cloud. Yeah, deploy your model. But now many people say, this model is not well because the result is not good. So you need to go back to some data, change your method in artificial intelligence, and deploy your model again. So I think this is a very, very complex machine learning and PyCon. So if you want to know how to do this, I think that this is just like DevOps. Now Microsoft said that or some professionals said that is MLOps. It begins DevOps. It's just like our DevOps PyCon. Because prepare data and build model and train model and reduce model, build image, deploy service. This is a circle of PyCon. Yeah. So the first thing is my machine learning on Azure. Everyone know Azure is my Microsoft public cloud, but Azure gives you all scenario in machine learning, just like that. Powerful infrastructure, productive service, and popular framework, and familiar data science tools, and to make a special pre-trained model. If you are professional, you can use some infrastructure and productive service, just like Azure Machine Learning, and just like you can choose a CPU, GPU, and FPGA to training. Of course, now Microsoft loves open source now, so many deep learning and framework support in Azure, just like PyTorch, TensorFlow, scikit-learn, and Honest is very popular framework. So you can use this framework, many open source frameworks in Azure. Another thing is familiar data source tools. Microsoft, you can use some Visual Studio Code or Jupyter Notebook to your machine learning projects. Of course, it supports PyCon, and command line is of course it can do the same jobs. Today I will introduce some portrait model because if many companies not have artificial engineer, so artificial intelligence engineer. So they want, if they want to use some artificial intelligence projects, they want to use some public cloud support portrait models. Azure gives you vision, speech, language, and search portrait model on Azure. This we say this is cognitive service cognitive service. Because we focus vision, speech, language, and research. Just like vision, object detection, and some face recognition and emotion recognition. I think this is always a scenario, in different industry. Just like that, you can use some OCR project. You cannot write some code. Microsoft gives you a portrait model about that. You can always use Python to call API. In Azure, you can use OCR function now. Just like that, you can use a speech, language, and web search in Azure Cognitive Service. Bring AI. Why we choose Azure Cognitive Service? Because it can build AI service. It can reduce your project progress step by step. You only use your language to finish this AI project. Of course, this cognitive service, it will support different AI platform. Just like that, we can put them in the Skype and some just like Zoom, just like Microsoft Teams and Facebook Messenger is the same. So this is very good. Bring AI to every application, and this is all scenario to AI applications. Microsoft Cognitive Service can do all the scenario. How I can do I can call Microsoft Cognitive Service is very important. Today I will introduce vision function about that. If you want to know some speech, language, knowledge search, you can find these resources to Microsoft Learn. But today I will only focus a vision and scenario. Just like I said, we can in the computer vision, we can use portrait and image tagging and object detection. Today, we can use object detection and landmark model and logo detect and some race detection and image detection. Understand over different things. This is the some numbers about that. But today our roadmap is a portrait, image tagging, and object detector can understand in 10K different things. Yeah, model available. We can push this model to Docker container. Just say you can use Azure Cognitive Service in the Docker and put you can let your artificial intelligence and Azure Cognitive Service run everywhere. I think we want to know how which scenario is suitable for this. Just like the AI scenario and some object counting and some automatic image tagging and for indexing and searching across video or image corrections. So you can find that object detection. You can find this picture. You can see. You can count how many cars in this picture. Another thing is we can search the landmark. Another thing is image captions. Because today many people give you some pictures, computer can tell what's this and how to do this. Just like that, this is motor bicycle, and you can a computer can set which bike do you like. This is image captioning and commenting. Yeah. Possible scenario is automatic general image caption for accessibility. Automatic generate image comments for people assistance and personal interactions. So this is very good scenario. Another is OCR. OCR is a very popular functions in different scenario. We can use some document OCR in 26 language, handwriting OCR in English, but we let the roadmap is multi languages support that. We can I can show you some cases about that. The first thing is, okay, we can know that if you want to use some cases about OCR, we can use a Microsoft Cognitive Service. Just like that. How to do this? We can if you want to try if you want to try some Azure or already get Azure account, you can sign in your Azure portal. This way, great resource. Yeah, you can choose great resource and then AI plus machine learning and select this computer vision. Yeah, this is a very basic Azure Cognitive Service functions. You can select this computer vision and select subscription. Of course, if you have some Azure for students and some group about that, and some region and some name and some pricing, you can use free pricing. Of course, if you have more cost per second, you can select standard S1. Yeah. Just I have already great computer vision about that. You can see this computer vision.
Sorry to interrupt. Are you showing on another screen for the live demo, something like that?
Yeah. Oh, okay. Sorry.
Because we because last.
Can you see this screen?
Yeah, student demo. Yeah.
Yeah. Okay.
Yeah. Thank you.
Okay, this is I have some technology problem about that. Yeah, okay. You can see the computer vision demos. Yeah. I create if you are successful to create the computer vision function, you can get this endpoint and some manage keys. You can get this now, and then you can use Python to input subscription key and endpoint key from your Azure portal, and then use Azure Cognitive Service SDK to call this function. You can see that you can not focus OCR how to write some OCR coding. You only need to focus how to use Python to call Azure Cognitive Service API. So this is a notebook about that. You can use this to call SDK and use some image, you can get the result. Another sample is I want to get some medicine information, and this is medicine pictures. You can see some simple Chinese title and something about medicine function. We can use this step by step. Just like that, we can use OpenCV and get image, and then we can use some Python API to call or recognize URL. This is OCR function URL in the endpoint and some keys. Yeah, you can get the result, and the result will give you the some title and some characters in the medicine. So this is very easy jobs. You cannot use some OCR function. If you in traditional you want to use OCR, you need to test web library. But now you only use API to finish this project. Okay, continue. Okay, Azure computer vision always can not only focus OCR or some image. You can use some face. We can get face detection about that. Each face landmark we can get 68 points. And low map, of course, we can focus some 3D face modeling. And this is a very good scenario in face API, just like authentication and some interactive install kills, people counting and crowd and analyze. Yeah. Of course, we can use the computer vision in Azure in real-time video analyze, just like face detection, checking, merging, age, and gender. This is the result. It's very more in some company. Yeah, it's very interesting. Yeah. Okay. Many people say, oh, okay, this is just a core API, but any more functions for some Azure in public clouds, we can use custom image classification. Just like that, if you can access custom vision.ai website, you can use this. You can give some low code project to train your image classification or object detection in custom vision with no some deep learning framework. Of course, the train model you can download to deploy Android, Onis, and iOS, and some cloud service. You can. I will show you some samples about that. The first sample is in the custom vision. You can access custom vision like this. You can input custom vision.ai. It will let you to join the this portal. You can see that the first thing is a mask demo. I will set some mask pictures in that, and I want to detect some people with mask or without mask. So the first thing is tell the upload the mask picture, and then I'll give some tests about this is mask. Yeah. Of course, you have no training in any codes. You only click this button and train for finish for this. You can see the prediction result. Okay. I will set some. This is very famous Hong Kong people in Olympic Games, Zhang Galong. Yeah, I think we can try to detect the mask. you can see that, okay, you only use custom vision to finish this. But people say, oh, this is cloud solution, but I think I will give this model can export to anything. Yeah. Just like I click the performance, you can select export. You can see that Core ML and TensorFlow and Honest and Docfile and OpenVINO and some Vision AI Dev Kit. You can choose your solution in different platforms. You can download this model to deploy different platforms. Just like that. Why I choose this solution? Because I think now this is Honest ecosystem. Yeah. Because today custom vision can export Honest. Honest because the first thing is many product team wants to use ML. Yeah. Reality is different training framework. We need to focus different model times. We need to deploy a different target, just like CPU, GPU, FPGA, and NPU, and put them in the PC and mobile and cloud. So different training framework and different device, different hardware. So Honest is the file time and to model time to give different deep learning framework model to change Honest to put to the different device, different hardware. More ML models research to productions. Of course, how do I get this more Honest model? You can download the model soon, and Azure Custom Vision can support Honest. So, if many computer vision project need to publish to IoT device, so we can change the Honest model time. Yeah. We support Honest in open source converting for popular framework, just like TensorFlow, Keras, Scikit-learn, and CoreML. So our latest support PyTorch and CNTK. So you can use this Honest to deploy to the IoT projects. Just like that, you can use PyTorch to finish this Honest change. Yeah. And some Keras, some TensorFlow is good. So you can see that we can, if you choose Honest project, you can use this just like that. I export the custom vision Honest model here and give some label. You can see that I can use Python to call Honest model. It can detect the mass in the local environment. Yeah. Of course, many people say not only for your local device. I want to put the Honest in the IoT project. You can see that if you this is my Jetson Nano device. I can put the Honest model in the device using Doc. Just like that, I set the Docker file and set this use NVIDIA TensorFlow Doc for Jetson Nano. This is support TensorFlow 2.3 and Python and TensorFlow Python 3. You can set some Docker, some library in the Docker, and it will build the Docker. You can see the result about that. If I call all this Docker, just like post API, you can see the Honest can analyze and give you some results about that. So I think Honest is very important to the computer vision because it let your model can push to different IoT device and in the Unicode model time. Another is after I finish a data preparation, another thing is model building. Of course, you can use Python and some different deep learning framework. Just say, of course, many people focus model training because many people say if you use public cloud service, it's not very good because I want to change some data, some method. So Microsoft Azure will give you Azure machine learning and scenario. This is just like you can use Docker container, or of course model repository, just like CI/CD, Py9 and check experiments is very good. So you can see that mobile deployment, it can, if you use Azure, you can push your model in your in different service. So you can use a simple VM and cluster, VM and Sparkle cluster to finish about that. Of course, security, you can use when you deploy at the edge, the E2E security must be maintained. Models should be deployed and data transmit only to security authenticate device. Monitoring the status and performance and security. The time is very limited. I will show you the Azure machine learning and portal. Please wait. This is Azure machine learning portal. You can use some notebook in the Azure machine learning. You can select the compute, different compute in the Azure machine learning service. So you can use the notebook about that, but I think the network is not well. So this is okay. You can see that we can train model in the Azure machine learning. This is a good choice because you know hardware. You cannot lock so many GPU, so you can use public cloud GPU in that. So Azure give machine learning will give you this GPU to finish your machine learning jobs. Another thing is automated ML. Just like you can use automated ML. Automated ML is very new technology in machine learning, because you see this. If you want to change the method or some algorithm, you need to lose many times. So automated ML will give you parallel how to finish different machine learning jobs. Of course, you can use designer. Just like that, image classification, you can use designer to finish about that. You can just like finish some Windows application to drag and drop some function about that. You can see that some data set, some split image directory, and some function, and some trailing. You can use PyTorch model trailing in PyTorch. You can use some drag and drop function here. And some model score. So I think Azure will give you all the scenario all in machine learning. You can use very easy custom vision. You can use a very professional function. Of course, you can use some drag and drop function about that. So I think use public Azure cloud service in machine learning is very good choice. Okay. Thank you. Hi, Sammy.
Thanks, Kim Fei. So if you have any questions to Kim Fei, so you can raise your hand to ask the question directly. Yeah. or you can type on the chat, so we can pick one to two questions. Yeah. Yeah, and for those participants who ask questions, he or she will enter an opportunity to receive a prize from one of our sponsors.
Any question?
I don't see any question yet. Yeah. Yeah. Maybe we wait for another 1 minute to see any questions coming on chat. And Kim Fei, can you share the screen which have your contact? Yeah, so they can contact you with they have some private follow-up questions. Yeah.
Okay, this is today's event resource. And oh no. I see the question because people say Microsoft is no open source. How to convince people to pay to use? Microsoft is open source now. You can use different jobs, just like a custom vision. You can register free account to finish 2 projects. And another thing is, if you want to do more or some open source project, you can use NNI project please wait. You can use Microsoft NNI project. This is a machine learning project, is neutral network intelligence. This is open source project, can help you to finish automatic machine learning and some machine learning case. Of course, Azure machine learning is on the cloud, but now you can use this open source project to finish your machine learning jobs. Yeah. This is a Microsoft open source project in machine learning.
Yeah. So any other questions? So we can have one more questions. One more quick questions. Yeah.
Another is if you want to get this event resource. Another thing is if you want to find me and get the resource today resource, you can access my GitHub and some or email to me.
Kim Fei, can you share your contact information on the screen?
Yeah, that's right. This is my contact information, and some if you want to subscribe to our free monthly developer
we still see your browser. Yeah.
Okay. You still my browser?
Yeah.
Okay.
Yeah. Okay. Yeah. 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 We found it. Yeah.
And another is this is a event resource. You can scan QR code to learn some computer vision AI.
Yeah. And we will also share the presentation slide on our conference website. Yeah.
Yeah.
Okay, it seems yes. Okay, one more question is coming up.
One more question.
So let me see. scanning. Okay. Maybe I copy to the public. Is this a question?
Yes. I think I will give you if you want to some parameters needed to set. Of course, this is some experiments. Just like computer vision, you need to set some parameters. In our case, oh no, sorry. Just like our custom vision, you can choose these different parameters. Probability overlap. Yeah, this is settings. You can choose this. Of course, you can use Azure machine learning in the portal. You always you can set some parameters. So I think many people think this is automatic jobs, but this is not automatic jobs. About that, just like this will give you some automatic method, but not automatic jobs. Yeah. So I think I know your problem, but now it's not very well now. Okay.
Okay, thanks Kim Fei for the presentations. Yeah.
Okay, thank you.
Hope that you will share with us again in the future. Yeah.
Okay, thank you. Bye.
Bye. So we will have a short break. So the next session will start from 3:45. Yeah. And the next session is Level Perfect, a powerful AI framework for time series models by Kaya Paseng from India. So it's time for us to back to the conference after 15 minutes break. Yeah. So the next sessions will be is that Kaya Pasen from India will share about a new provide a powerful AI framework for time series models. So I now pass the time forward to the Kaya Pasen.
Thank you so much for the warm welcome and the quick intro with my talk. So today I'm going to talk about Neural Prophet, a powerful AI framework for time series model. Before that, let me quickly introduce about myself. I'm Kalyan Prasad, a self-taught data scientist and analytics manager working with one of the startups based in Hyderabad. And I'm also a community first person. I love being involved with so many communities, and I've helped so many communities to grow. Currently, I'm a core member of these following communities like HiPy and PyCon India, PyCon Hyderabad, and also Humans for AI. And I'm also an avid speaker. I also love to give back to communities most of the time. So that's why I always look for opportunities to speak and share my knowledge with the communities. And I'm also a lifelong learner because there is so much things to learn in a life, so you cannot master everything in a single day. So that's what set of a mindset which I have with me. And I also mentor folks who reach out to me on different aspects of health. So I'll guide them accordingly. That's pretty much about me. And here is the agenda for today's talk. So we'll start with quick intro to time series. Then we'll talk about what is Neural Prophet and why we need exactly Neural Prophet and what are the difference between the original Prophet and the Neural Prophet. And then we'll straight away jump into the action. We'll see some hands-on about Neural Prophet, and then we'll conclude the talk accordingly. Without any further delay, let me get started. So introduction to time series. So there are so many definitions on the time series which are available on the internet, out of which indicate same meaning in a different way. A traditional straightforward definition of a time series is sequential data order matters. So when we are talking about time series data, the main aim is to estimate how sequence of observation will continue in future. So observations are typically collected at regular intervals like every hour, weekly, daily, yearly, monthly, etc. For example, if you are talking about weather data, we may receive weather updates for every 10 minutes or every hour. Or if you are talking about something about IoT sensors like that, where we receive the data continuously. So depending upon the source of the generation, we may have different frequencies at which data is collected. Advancements in machine learning have increased the value of time series because there are so many prediction problems that involve time series component. That is why it is like booming in the industry now. Organizations also apply machine learning to time series problems to make informed decisions. They also do some forecasting in order to understand seasonal and cyclic patterns. That's the reason because time series forecasting helps us to predict the future values of a critical field which has a potential business value in the industry. I believe that time series has completely spreaded his wings. That is why it is like everywhere in the industry. Now, here comes our main topic, Neural Prophet. So here's a quick visual representation about Neural Prophet. So it is a Python library for time series forecasting. Neural Prophet is based on neural network that uses PyTorch as a backend, and it has a modular architecture that allows so many features to be plotted in the future. And this library is heavily inspired from Facebook Prophet and ARNet libraries. And this library was developed by researchers in collaboration with Stanford and Monash University. And now, what more we need to know about Neural Prophet? This library is completely beginner friendly. One can easily set up and start building time series model. So you will see that in just a few moments. It also addresses pain points such as scale, customization, and extensibility. So what does it mean? Means this library or model is completely scalable, and you can also customize the model or adjust the model according to your needs. And the other thing is, of course, you can also modify or edit the code without modifying the existing core base. Just like profit, neural profit is also decomposable with all time series components like trend, seasonality, auto regressor, laggard regressor, future regressor, and recurring events as well. This library is absolutely an updated version of Profit because it uses deep learning models such as ARNet for forecasting time series models. Now, why we need exactly neural profit? It aims to solve the seesaw of uncertainty. So what do I mean by here? I assume you are aware of AR models. So AR models are nothing new, but usually we would use linear regression fit with least squares instead of neural network fit with a backpropagation. ARNet mimics the traditional AR process with a neural network. So it is a single layer network that is trained to mimic the AR process in a time series signal, but at a very larger scale than the traditional models. ARNet also scales much better to the larger data sets and more inputs. For example, if you look at the below graph, it shows that the training time of ARNet doesn't increase exponentially when compared with AR order. So this is the ARNet graph and this is the AR order. It doesn't increase exponentially when compared with AR order. One thing I would also like to talk about here is about the p-values. So the p-values here are the number of the values used, number of the autoregressors used in the AR model, not that p-value which we associate forecast in the hypothesis technique. So this is something you should really keep things in mind. Apart from ARNet, neural profit also upgrades profit linear external regressors to feed foreign neural networks because deeper is equal to better, which means the better we get the model, so the better we get the results and the better we have accuracy. Last but not least, adding neural network to the profit has a downside because it increases the learnable parameters dramatically. To cope up with that, neural profit relies on PyTorch framework as a backend instead of a STAN, and it trained with stochastic gradient descent. So STAN is nothing but the state-of-art network which for statistical modeling and highly computational for statistical performance. And here comes the difference. So as the name suggests, neural profit is similar to profit, but it throws neural network in the mix to spice up things. When you are exploring time series data at any point of time, you will definitely encounter a popular package called Facebook Profit. So this library has gained a lot of popularity due to the fact that it provides a very good results in terms of accuracy and interpretability. And the best part of the Facebook Profit is it automates a lot of elements for the user, such as hyperparameter selection, feature engineering, etc. That is why this library is very straightforward to the user, like data scientists or any other folks who are playing with the time series data, or even for the folks who has very less knowledge, they can easily use this library. And when it comes to neural profit, the author also had the same thing in mind while developing this library to retain all the advantages of the profit while improving accuracy and scalability. So, and using ARNet to combine the scalability of a neural network with the interpretability of AR models. So here are some of the core differences which are featured in the neural profit comparatively with the original profit. The first one is like gradient descent for optimization. So neural profit relies on PyTorch as a backend, which makes model much faster. The performance of model will be much faster compared to with profit. And time series autocorrelation is modeled using the AR autoregressive neural network, which is again a very good advantage. And laggard resources are modeled using a separate feed-forward network. As I mentioned, it takes a separate feed-forward network for the laggard resources. And the model is also configurable to non-deep layer parameters of the feed-forward neural network. This is again a biggest advantage in the performance will be like, massive. And it also offers custom metrics and losses. Apart from these features, another great feature of a neural profit is it gives a developer access to the ARNet library, which was developed by Facebook. So That's these are the core differences for the neural profit, which makes the model much faster. I think I have given so much GAN on theory. Let's straight away jump into the action now to see how neural profit performs in real time. So let me switch back to my code notebook now. So here is the code notebook for neural profit. So basically the goal of this notebook is to show you about neural profit and how it is used for time series modeling. And I'll also show some various techniques to visualize and manipulate time series data, and also show some important various techniques which are involved in neural profit. So when it comes to installation of neural profit, so there are similar ways you can do it. So the straightaway process is you can simply pip install neural profit, or if you want to run neural profit in a Jupyter notebook, you need to install neural profit live. So this will allow you to enable the live plot loss in the fit function to give live plot for the training and validation loss, so which you will be seeing in some time. And if you want to get an up-to-date version of a neural profit, so simply you will just go to the GitHub page of a neural profit and clone the repository and start playing with it. So in this, so for this demonstration, so in my case, I have installed the live neural profit. So it took some time to install because this package is a heavy package and it uses Torch. So that is why the loading time requires 2 to 3 minutes of time. So which I have already installed here. Again, I'm running for you now, so you can see. So it takes 2 to 3 minutes time. Okay, it's already done now. Okay, cool. So basically this notebook consists of a 2 section. In the first part of section, we'll be talking about creating a simple baseline model of a neural profit. In other section, we'll dig into bit detail about neural profit and we'll see what are those things. Okay, so as usual, we'll import necessary suspects here. So I have imported necessary libraries like pandas, matplotlib, cbon, and from neural profit, I have also imported random seed, and I have set random seed with random number to ensure that results are reproducible on subsequent model run. So here my random number is equal to 0, and I'm loaded my libraries. And for this demonstration, I have taken the retail CSV data, which is from neural profit page. So have run the data. So here are the first 10 rows and here are the last 10 rows of our data. So just like profit, neural profit also need to require some reformatting on our data frame before we pass to our model. So what I mean here is so we need to make sure that our date column is a correct data type, and this should be named as DS, and our Y parameter, which is the predicted value, should be named as a Y. So in our case, which is already done here, so there is no need to do reformatting in our case. So we can simply proceed further. So creating a simple model. So in neural profit, we can simply create a model and validate with very few less lines of code. So let's see that. So what I've done here is I've initiated a neural profit here. So there are so many options and parameters are available in neural profit, which we can pass to our model to improve our results. But for now, we keep things simple and let's build a simple model here. So I'm just initiated the neural profit model, and then I'm calling my fit function, and I'm passing my data and other 3 parameters called validate each epoch. So validate each epoch is nothing but whether or not to validate the model performance on the validation data for each epoch. So valid P is a parameter, which is a float parameter between 0 and 1, indicating that the distribution of a data should be used for training. And plot live loss is nothing but to get a live plot for training and validation loss. Frequency D is nothing but we are using a daily frequency here. Epoch is nothing but the number of epochs that should be used for training. So let me run this. So it takes few seconds to run it. Okay, it is running. So if you observe and notice how the plot and live loss are changing after each epoch. So did you notice that? So let me also rerun it again. If you notice the plot, okay. So if you see the plot, how the plot and loss values are changing after each epoch. So that's the beauty of a live plot. And now we'll generate a prediction. So to generate a predictions for a neural profit, we need to have a future data frame. So as the name suggests, we need to create a new data frame of the day that extends our original data frame. So what I'm doing here is, so I have passed my model and I'm creating a future data frame, passing my data here, and period is equal to 365, which means that I am creating a future data frame of a 1 year future data frame here. Then I am passing my future data frame to predict function so that it will return the forecast. So once I execute this, so here we got our future data frame. So if you also notice, so our data starts at 1992-01 and our data ends at 2016 1 May. If you look at our prediction future data frame, it starts at the May 2016 second and it ends with 2017 one. So we got a 1 year data frame now, and it also identifies the y-hat predictions, trend, seasonal, yearly values as well. So that's again the beauty here. And one thing you should also remember here is it is common that y and residual values to be none. So that is the expected behavior. So you don't need to find that. So we have created a future data frame. Let's plot our model forecast. So it's very straightforward. We just need to pass the future data frame here and we are to our model.plot. So it will generate the plot here. So notice how model is able to learn the seasonal pattern for our retail sales data for on our future data frame. And you can also plot the model plot component. So this process is known as the time series decomposition. So if you look at the trend took a very solid downward trend here. And if you also look at this graph, the seasonal ELT, particularly January is quite the busiest month comparatively with other months. So if you see the seasonality, December being busy month comparatively with other months here. So these plot components are very important for domain experts because they visualize these plot components to see insight. They visualize this component to visualize on the overall forecasting process and adjust their model accordingly. So these plot components play a very important role in the model building. So so that's pretty much about building a simple neural profit model. So it's very straightforward and very easy. So we check that. When here we comes to our next section. So in this section, we'll see why neural profit is so powerful. So when it comes to neural profit, so neural profit is especially powerful for time series forecasting because it takes additional information into account such as trend, seasonality, ARNet, and recurring events into account. So we'll see all these items one by one in action now. So for this demonstration, I have taken a different data source from Kaggle, which is called Nifty 50 data. So it's a Maruti company here. So I have taken the Maruti CSV, passed the Maruti CSV, and I'm reading my data here. So here we got first 5 rows and of a data. Then here you can see the quick info about all our columns which are available in our data frame and about date type, everything. And if you also look at the shape of our data frame, so we have total 4,427 rows and 15 columns now. Okay, as I mentioned earlier, we first need to reformat our data before we pass it to our model. So this is what I am doing here. So I have created a new data frame variable here, and from my original data frame, I am selecting date and VWAP column. So VWAP is nothing but the volume weighted average price. So volume weighted average price is a trading benchmark for traders that gives an average price of a security traded throughout that day. And this price is really important for traders because it gives an insight to both trend and the value of a security. So for this demonstration, so I am taking my future prediction price as a VWAP. So then, as I mentioned earlier, so date should be the current date type. So in our case, the date is actually an object, so it should be a date time stamp here. So that's the reason I'm converting my date from object to date time. So this is what I have done there. So once I execute this, so we'll get a date and volume weighted average price values. So let's start with the trends. So what I'm doing is I've selected my data frame and passed this column and just simply plotting to see how my volume weighted average price has been. So if you look at this graph, it shows a general increasing trend with small changes where prices rise or falls sharply. I mean, like most of the graph looks a sort of increasing trend where where there are certain places where you see price rises and falls sharply. So we can consider these as a change point. So with this in mind, we'll now train a neural profit model of our volume weighted to predict our volume weighted average price by only focusing on the trend as our first version of our model. So we'll now build only considering a trend as our first version of a model. So then what I'm doing is, so we cannot pass date as a directly in our date column. So as I mentioned, so we just need to rename these columns into DS, and our predicted parameter should be as a Y. So this is what I am doing now. So I have done this. Now we got date as a DS and volume weighted average price as a Y. So we are all good. Let's now create a trend model. So with neural profit, we can create a trend time series model by passing only few arguments here. So I initialize the neural profit model here, and I'm passing few parameters, which is like n change points trend. N change points is nothing but specifying the number of points in the broader trend where a rate of price increase or decreases at any point of time. So trend is nothing but it's a regularization parameter that allows to be plotted of a changing point selection. So this is what it happened. And I'm giving this yearly, seasonal, daily, seasonal T as a false because right now we are focusing only on the trend. So the seasonality should be given as false. So then we're done with the initiating model, then I am passing my fit function to our data frame and also the other parameters which we have already seen above in our first section. Okay, now let me run this. So if you notice this loss plot, it looks much compromising, but however, it seems like after a lot of volatility, the model has converged. So what we can do now is, what we can do to understand better trend pattern here is we'll visualize our model predictions now. So in order to do that, what I have done is I have created a custom function called plot forecast, where I am passing my model data, periods, historical predictions, and highlight steps ahead is good enough. So model is nothing but our trained neural profit model here. Data is nothing but the data frame which we have used for a training, and period is nothing but the number of periods which we want to forecast. Historical predictions is nothing but whether we want to plot model predictions on a historical data. Highlight step ahead is not steps ahead is nothing but the number of steps ahead of a forecast line to highlight. So this is only used in autoregressive models. So there I am creating my future data frame here, and where I am passing my data and periods and historical predictions. Then I am passing my future data frames to predict function so that it will return forecast now. And I have also written a quick conditional statement here because, so what this means is if highlight step ahead is.
Hi, Kanya. We can't, sorry to interrupt, we can't hear you.
Can you hear me now? Can you hear me now? Can you hear me now?
Yes.
Okay. So is it audible now? Is it audible now? Can someone confirm in chat, please? Okay, perfect, thanks. Okay, so where I am, so I'm talking about this conditional statement here. So my conditional statement here is if highlight step ahead is not none here, so I want my model to highlight the step of head each forecast line. So I want my model to highlight all these things. Otherwise, I just simply want to plot my model forecast. So this is what I have done. Let me run this. Now I am calling my plot forecast function where I am passing my model and data frame and giving period as 60. So now we can visualize our stock price based on historical data and as well as its forecast data. So this plot includes the forecast plot on historical as well as a future. So let me also. So first, let's see this. So it is evident that the model is able to capture a general increasing trend for our stock price. But however, if you look at the model seems to suffer with underfitting here, particularly if you look at 2019 and 2020 period that was likely used for validation. So we can also better analyze this plot. So I'm again calling my function, passing my model, data frame, period, historical. So this is a forecast plot without not showing about the historical prediction. So this looks like a solid increasing trend here. But something I'll tell you in reality that if the stock price was that easy to predict, so based on this straightforward increasing line, if stock price was that easy to predict, no one in the organization would generally hire a financial advisor to manage their portfolios. Makes sense, right? Because this shows a solid increasing line. It was quite easy to predict here, but this is not happen in reality. So what we'll do now, so what we make our model much better. So we'll pass some seasonal parameters here to make our model more realistic. So let's do that. So here comes the seasonality. In most often, time series involve seasonal patterns, which is even true for stock market prices as well. So we'll pass some yearly seasonal parameters to our model and see how our model performs. So again, I will initialize my neural profit model and rest all parameters same. Only thing I'm changing here is the yearly seasonal parameter true, which means that I'm passing my yearly seasonal parameter and rest all remains the same. Let me run this module. So let's look at our live plot now. So the live plot seems compromising again here, and so it looks still some volatility here, and so let me call my function and passing my model data frame and predicting the 60 day, which means I want predicting for next 2 months, and spread is nothing but so where I want to have historical data as well. So let me plot this. So let me also plot the forecast plot here. So if you look at based on the above two plots, the model looks a bit realistic, but it still suffers with underfitting here. So the model is still underfitting in this particular year. And if you also look at the forecast plot, it shows a smooth curve which is of a yearly seasonality here. But in reality, there are very rare instances where stock price moves so smoothly. If you remember, most of the stock prices look with uneven and jagged lines. So if you they don't look like very straightforward lines or in smooth curve. So most of the lines will be zigzag and or uneven lines. So this is so what we can do better in order to improve this model. So we capture all this volatility now, and by using ARNet model, and we'll train with this ARNet model. So what is ARNet now? So ARNet is an autoregressive neural network model that is especially used for time series modeling. So autoregressive models are a class of models that are able to predict the future values of a variable based on its previous patterns. So we can train our ARNet model by passing a few parameters here. So let me initialize my model here, and so here I passed n forecast and n lag. So these are the parameters which I passed, which is nothing but, so we are training our model, and our model want to predict our prices of Maruti from the historical price to future 65, historical 60 days to future 60 days, which means that, so I want my model to predict based on historical 60 days to future 60 days. So these are not, this is what it means n lags and n forecast here. So rest all arguments remain the same. And again, now I am fitting my model here. So let me run this. So once I execute this, so we'll get a smooth loss MSC, MAE values here, and we'll see that now. It takes a few seconds because this is quite a heavy one, right? So definitely take some time to run. So please be patient. So far, if you have any questions, so feel free to drop out in the chat. So I'll be happy to answer in case if you have anything. So since the epoch values are 100, so it takes each epoch to run at least a few seconds. Okay, so here we got our loss values, mean absolute error values, mean squared error values, and reg loss values. So you see the values have a different volatility. So instead of looking at this number, so let's plot this to understand things better. So let me plot our ARNet model here, forecast model. So see the graph here, and let me also plot this model forecast plot as well, and then we'll talk about this. So based on the above two plots, okay, so this is a forecast plot and this is also a forecast plot including historical prediction. So based on the above plots, our ARNet model makes predictions more realistic here, makes more realistic here, and it also managed to capture the uneven lines in the moments of the stock market. So if you see the forecast, the model is able to capture the uneven lines in the moments of the stock market. So that is the beauty of the ARNet model here. So this is quite a good model so far, but what we can do even better if we want to improve this model. So we can take our recurring events into the consideration and see whether we can still improve our model. So let's jump into the recurring event. So often when forecasting time series models, we take recurring event into the consideration. So this is exactly what I'm doing here now. So again, I've initiated the neural net profit model and passed all these parameters here. Then I'm configuring my model to take the dates of the holidays into the account now. So I'm giving Indian holidays here. So because since Nifty is a national stock exchange of India, so I am considering Indian holidays here, and I'm also passing a parameters called lower window and upper window, which means that I want my model to capture the prices impacted before and after the holiday, which means that if today is the holiday, I want my model to capture the prices impacted yesterday as well as tomorrow. So this is what this parameter means here. Now I am fitting my model here. So let me run this now. So it takes a few minutes to run to get our losses and errors as well. So yeah, it's going now, going. It is 52. Okay. So the thing is, the process should be a bit faster so that we'll get the results quite quickly. Unfortunately, my process is a bit slow, so that's the reason it's taking some time here. So we got values of our loss function, mean absolute error, mean square error, reg loss here. So in order to understand this, so let me plot now our forecast. So so this is how our plot looks even after considering recurring events into the consideration. Let me also plot the forecast data here. If you all see, it also captured some movements here. But if I look at the ARNet graph and also the recurring event graph, there is no much impact here, even though after considering real recurring events into the consideration, there was no much change in the price. It remains the same. So, so what I want to conclude, tell you here is predicting the stock price is not that easy, but still our model has done a good job in terms of capturing a general trend patterns for our stock price. So due to the day-to-day volatility of the stock market price, I generally not recommend to use this model for your own trading, but I believe that this is a good demonstration of the capabilities of telling about the neural profit. Lastly, what I would like to tell you is there is so much thing that you can explore, do with neural profit, but hopefully this is something that you can. This is at least something that you can get started with whatever the explanation which I've done so far. So So that's pretty much about on hands-on. So let me again jump to my slides here. So here is a roadmap for neural profit. So one thing before I talk about roadmap, so there's something I should also mention here is this library is still new, and a lot of changes can happen. So you should remember one thing here is not all the features which are there in the original profit are already implemented in this neural profit. So for example, so logistic growth for trend component, this is something they need to add the feature. Support manual data, incorporate time series featureization, improve forecast accuracy, model bias modeling, and unsupervised anomaly detection. So all these features are yet to be added in neural profit. And if you want to refer the neural profit, so go to their page and GitHub page, and also look at the ARNet model page. And there is also a great article about comparing neural profit and profit differences. So feel free to explore and experiment, and let me know if you find out any interesting results. Feel free to share with me. I'll also happy to learn and gain things from you. And thank you. And of course, it's always take the time to take seriously. And that's pretty much from my side. I'll happy to take questions if I have anything. I'll stop sharing my screen for a moment now.
Yeah, thanks for your presentation. So, with the participants have any follow-up questions to Kanya, you are welcome to contact him. Yeah, we will share his slide on our conference website, and also we will edit the video and then upload to the YouTube as well. Yeah. So you and the participants can also find the some of the content information on the in the chat folder. Yeah. Also find the Kanyan personal information, just like Twitter and LinkedIn on the conference website as well on his sessions page. Yeah. So thanks, Kanya. So next sessions will be start in 3 minutes. Yeah, by Alejandro Sasento.
Okay. So, sorry, I didn't get you. What you were saying? Sorry, Shami, I didn't get you actually. What you were saying?
We will start the next session. Yeah.
Okay, so thank you so much for the opportunity to speak at PyCon Hong Kong, and it was a really great honor to speak at your place. Thank you so much.
Yes, thanks, Kayan. And we hope that you can recommend our conference to your friends as well. Yeah.
Sure. Thank you.
Yeah. Thank you. We will start the next session in 2 minutes. Okay, so we are back now. This session will be the last session of today conference. The next session is pitching the data science gap in production machine learning with Tempo GP2 at scale. The speaker is Andrew Sacendo from London. So I pass the floor to Andrew.
Thank you very much, Sami. Should I wait for you to start recording?
Yeah, okay.
Perfect. Thank you very much, and welcome everybody to my talk, Bridging the Data Science Gap in Production Machine Learning with Tempo, GPT-2 at Scale. So just as a heads up, you will find the slides in this link at the top right, and you will be able to find the reference to all of the open source examples that we're going to be covering in this session. So a little bit more about myself. So my name is Alejandro Saucedo. I am engineering director at Selden Technologies and chief scientist at the Institute for Ethical AI, as well as governing member at large at the ACM. So a bit more about Selden. So Selden is a machine learning deployment and monitoring open core company. So we basically have one of the most popular open source Kubernetes-based machine learning deployment frameworks. And as a company, we offer enterprise management of machine learning at scale for serving, monitoring, observability, etc. And the Institute is a research center based in the UK, focused on the design, development, and standardization of the responsible use and operation of machine learning systems. So today, what we're going to be doing is delving into a broad range of very interesting topics. So this will include talking a little bit more about what we refer to as the data science gap in MLOps or production machine learning. And we're going to then talk about some ways in which we can address this gap by making it easier for data scientists to productionize models at scale. We're going to be doing this using this framework called Tempo, as well as Selden Core, Triton, and a couple of other frameworks like Onyx and ML Server. And we're going to be taking a very practical use case. So it's going to be quite an interesting session. So we're going to be talking about quite a lot of relevant topics. So to start with, let's talk about some of the challenges that data scientists face when scaling their machine learning capabilities, right? Once they train a model, they want to make it available for business consumption. One of the things that data scientists end up getting stuck is dealing with the complexities of production software, right? And this, of course, tends to happen more once you start having more than a couple machine learning models in production. Some challenges that make it more complex are things like the specialized hardware that is involved, right? The fact that in some cases for inference, you may require specialized hardware like GPUs or even TPUs, large amount of memory, and then the scaling of those components. There may be some complex dependency graphs for data relationships. There may be some compliance requirements that may become more critical as the production machine learning models are being used in more critical environments. And there's also the need for the reproducibility of the models themselves, the code, the data that goes through them for both diagnostic and auditability purposes. And the key thing that we're starting to see as well is that there is an increase in what normally is referred to as MLOps platforms. These are basically end-to-end, large scale or at least larger scale systems that allow data scientists to productionize their models throughout the entire machine learning lifecycle. So the data processing, the data labeling, the feature engineering, the training of the models, and then the serving and deployment of the models, the monitoring of the models, the evaluation of the models, et cetera, et cetera. Now, one of the challenges that we see is that even though these MLOps platforms do introduce capabilities to scale models, they do introduce a lot of potential red tape and limitations, specifically to the data scientists, still creating barriers that limit and introduce deeper involvement and kind of suboptimal processes between the data scientists, the machine learning engineers, and the DevOps personas. And ultimately, the main way to address this is to ensure that when a data scientist is able to create a model, they don't have to wait until it's deployed in production, such that they have to ask a DevOps person to see why it failed, or to fetch the logs, or to have to look at the Kubernetes environment, because the data scientist would not want to, or would not require to actually delve into those level of infrastructure complexities. Now, the proposed way of addressing this is through functionality that would be targeted, or tooling that would be targeted for the data scientists to be able to test, evaluate, and extend as much as they can in their training environment, such that when the models are handed over for those latter production environments, those are actually fully tested, they are much more robust, and they are going to be working as the same sort of expectations as they had in their training environments, providing some tooling that makes it all easier. So the way that we're going to show how to do this, we're going to be taking the GPT-2 model. And the reason why is because this is a slightly more complex, more advanced, state-of-the-art machine learning model. If you are familiar with GPT-2, what this allows you to do is to provide an input text, and the model would be able to predict what could be the next token to generate text. And it actually has been used for a lot of very interesting use cases to provide human-like text generation. So examples of this include online text games, adventure games that allow you to create a full-on environment and interact with it in a pretty special and specific way, as well as other potential use cases that allow for automatic generation of text, right? So this is a very interesting machine learning model that has been trained on, millions of parameters, or a very significantly large, data set that we would benefit from being able to deploy in specialized hardware in scalable environments. So that's why we're taking this use case. How we're going to do this, we're going to, as mentioned previously, use Tempo to simplify the productionization process for data scientists. We're going to first fetch a pre-trained GPT-2 model using the Hugging Face library. This is going to be a TensorFlow model. We're going to optimize this TensorFlow model by exporting it into the Onyx format. We're going to talk a bit more about that. And then we're going to be leveraging Tempo to allow data scientists to first deploy their model inside of Docker in their local environments without having to deal with any of the complexities of the overall machine learning engineering complexities. And then once they're happy with the way that they can interact with the model, they're going to be able to very easily just push it to Kubernetes into a highly scalable environment without having to deal with any of the complexity, using this framework called Seldon Core as a Kubernetes backend, but without having to deal with any of the complexities. And this will become a little bit more clear as we delve into the actual hands-on example. As I mentioned, the example and links are on the slides, and you can find them over here. So let's get started. Let's first fetch the model and optimize it. As I mentioned, we're going to be using the Hugging Face library, which is a transformer-based library that has a vast amount of pre-trained models that you can actually leverage. And it is as simple as just importing from the transformers module, the GPT-2 tokenizer and the model. We will see why we need a tokenizer and a model, but this is as simple as just fetching it directly from their library. The reason why we actually need both the tokenizer and the model is because, let's take this example. So let's assume that we actually want to provide the model this input of I love artificial intelligence. We would actually store this in a variable. We would then actually use the tokenizer to first convert this text into machine readable tokens that then the model would be able to process. In this case, it would be the bunch of tokens, which are the representation of each of the words, which then we would be able to provide to the model to generate our text. So now we would get as the output of the model, the generated text of, I love artificial intelligence, but I'm not sure if it's worth, right? So it's actually generating human-like text by just using the model. Now, one thing that we need to remember is that the model can only generate one token at a time. It actually predicts the next token. So whenever we give the entire text, it predicts one token, then we use the new text to predict the next token, right? So here we're saying I want to generate, maximum of 20 tokens. But this generate function is actually abstracting a lot of the logic. The reason why I'm talking about this now is because once we productionize the model, we're going to have to actually write ourselves the logic of this generate. So the way that this is actually doing it is using the greedy algorithm. What that means is that whenever you perform a prediction with the GPT-2 model, what you actually get is the probabilities of each of the tokens to be the next token, right? So what we're going to be doing is just take the next immediate highest probability. Of course, there are other algorithms that can be used, like beam search, that allows you to actually look at several kind of like steps beyond before you actually take the next token. But, this is not a GPT-2 talk. This is a talk about bridging the gap in production machine learning, making it easy for data scientists to create and orchestrate complex logic without having to deal with infrastructure complexities. So now let's have a look at how we can start optimizing and productionizing this model. The first thing that we're going to be doing is optimizing it using the Open Neural Network Exchange project. This is a Linux Foundation project that allows the exporting of TensorFlow, PyTorch, and other type of deep learning models into a format that is not just easier to manage, but also it allows for deeper optimizations, right? So it allows for better performance and more sort of nuanced optimizations, right? So we're going to just be using a simple command to take a TensorFlow model and convert it into that ONNX format. Now, the question is, we're talking about running it locally, right? So far, I showed you how you can run it on Python, but how can you go from, I can run it in my Jupyter notebook as a model into I have a, service that can be consumed for business applications, right? Like the game that I was showing you earlier that was able to allow users to actually play a text-based adventure game, right? How can I expose it into that without having to deal with all of the complexity of the infrastructure? And this is where we are going to start leveraging Tempo, and we're going to be productionizing the model into, what would be a optimized NVIDIA server, as well as to run it in local Docker, and then productionize it into a scalable environment, right? And this will become a little bit more clear of what that looks like. So what Tempo gives us in order for the data scientist to be able to productionize their model, it allows you to actually abstract it into a simple set of steps. The first step is to define the model wrapper, right? So this is basically the specification of what is the framework of your model, what is the path to the local artifact that we exported, that is the ONNX artifact, what is the specific name that you want to give, and other perhaps configurations that you want to have. So we define the wrapper for the model itself. Then we can run the model in Docker and perform predictions, right? It's very much as simple as that for us to run it in Docker. But then if you remember from what we were talking about, our model only predicts the next token and it uses tokens. So we need something that converts our human readable strings into tokens and then calls our model multiple times, right? This is where we can actually use Tempo to define a custom pipeline. And this is basically custom logic that can be orchestrated, that can be used to orchestrate some specific steps that can interact with a single or multiple models, right, that we have already defined. So we're going to define our custom pipeline, and similar to the previous one, we can run our pipeline and our model first in Docker, right? So the model is going to run in NVIDIA, and the pipeline is going to run in a Python environment that Tempo provides. And finally, the actual step to deploy it into Kubernetes is as simple as just using one function, given that we've already tested everything, we are happy with everything, and we can just proceed. Now, let's actually see what this really looks like. So the first step to define the model wrapper with Tempo, what we have to do is just import the model from the tempo.serve. This allows us to then define what would be the model name, the actual platform, which in this case would be model framework.onyx, right? If we didn't convert it to Onyx and we just deploy the TensorFlow or the PyTorch one, we would be able to use model framework.tensorflow or model framework.pytorch, right? So it's as simple as defining one of the many supported frameworks. Then we actually just define where is the folder, the local folder, where we actually have the Onyx artifact. And then we can actually provide a remote bucket that we can then use for the production use case, right? Because ultimately, in order for that to be a scalable service, it's going to have to be able to fetch all of those artifacts. But we'll get to that in a bit. Right now, all you need to do is that it's as simple as just defining this wrapper, and then as simple as running it into the Tempo local runtime. So the way that we do that is we just import deploy local from tempo.serve.deploy. We then run our model that we just defined through that deploy local function. We then get that remote model, which is actually running in Docker using Triton. So we now have a service that is running locally with an exposed REST and gRPC API, which then we can very simply send a request. If you remember, because it's just the model, we need to send the tokens, and we're going to predict the next token. So locally, we have to provide the logic where we would take an input, which is this string. This is a test, right? We would then encode that string into the tokens, right? We would then get those tokens. We would then create the inputs that we want to send to the model, and then we would actually run that through the model using the remote GPT-2 model.predict. We would pass that, and we would receive the output. That output comes back in tokens, right? If you remember, these are all of the tokens, and we want to take the one with the highest probability. And when we print it, we see that the next token is the word off, right? So right now it's still relatively complex because we deployed a model that predicts the next token. The next step is to define the custom logic, right? If you remember, we have to devise the pipeline logic that is going to perform that comparison. So this actual logic, instead of using the model class, we're going to be using the Tempo pipeline class. We have the same sort of like similar configuration, but we now define where we want to store all of the sort of local artifacts, which will include the custom logic as well as this transformer, right? So if you remember, we're going to be using this transformer tokenizer in order for us to convert that incoming string. And the only thing that we need to do for Tempo is to define a predict method where whatever you send to the model, it's going to actually be passed through this custom logic. What that actually looks like inside of the predict method is basically what we just did, right? We would actually iterate for the number of tokens that we want to predict. And we would basically just take whatever input we receive. So in the previous example, it would be something like, this is a test. We would actually tokenize that. We would convert it, send it to the model, right? Because here we are actually using that model that we defined within the previous one, the GPT-2 model that we had previously, right? And we're going to be able to actually use that model.predict whilst Tempo does all of the complex logic behind the scenes. Now we have to then convert the output of the model into a string, and we need to append it into the initial string. And we just rinse and repeat, right? So what would happen is we would have the input string, this is a test. For the first iteration, the first token is going to be off, right? So then we would do it again with this is a test off. and we would get the next token, the next token, the next token until we're happy, and then we return the final output. The next step is to just run that pipeline and the model in Docker. So it is also as simple as just running deploy local of that pipeline. And we would then just be able to get that similar remote local object that we can call predict. But instead of having to pass the raw tokens, we can now just pass a string. So now we're passing the string, I love artificial intelligence. And then the response that we get back is, I love artificial intelligence, but I'm not sure if it's worth blah, 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 right? So this is exactly what we saw before, but now we have a fully productionized, service that is running and tested within our Docker environment that works. Now, this is what we have so far. We have been able to run that custom pipeline logic and that GPT-2 model in our local Docker environment. What we now want to do is to actually do the same thing and run that in our Kubernetes environment for the data scientists to not have to deal with any of the complexity, right? Because Tempo already handles the complexity of, okay, well, you have already your Kubernetes cluster over there. It would be running all the relevant stuff that your DevOps team may have configured. The only thing that you need to do is to say, I have already finished this configuration of my local service. I've tested it. I'm happy with it. Now it will be working in the same way in that production environment. Now, the step to actually deploy it in Kubernetes is the simple step of actually using the deploy remote function instead of the deploy local function, right? Whenever you actually use the one for Docker, the only thing that you had to do is use the deploy local. That's the default for the local environment. It uses Docker. For this one, we just use deploy remote and we pass the pipeline. That in itself just interfaces with Kubernetes to do all of the required steps to make sure that it's actually running as the relevant Kubernetes deployments, right? So it handles all of the complexity for us. We don't have to deal as data scientists with any of that sort of stuff. And the main thing is that right now I am actually showing you the imperative interface of the production process for Tempo, right? But Tempo also exposes something that DevOps and platform teams really care about, which is declarative interfaces. So you can actually also leverage the declarative interface of Tempo, which is a little bit outside of the scope of this talk, but you can check in some of the examples that I've linked in the previous area. So the key thing here is that once we actually run deploy remote, what we actually get is a similar object that allows us to interact with our remote model that is deployed in Kubernetes. And we can similarly send that input request of I love artificial intelligence, and you would actually have that same interaction between the pipeline and the model as separate services that you can actually just interact with. And similar to how we're interacting with the pipeline, you can also interact with the model directly. And this is the beauty of the framework Tempo, that it abstracts all of the complexity that you would normally have to deal with if you were actually doing this directly with Kubernetes and directly with this framework called Seldon Core, that is basically the backend, the backbone that is doing all of this machine learning orchestration. So that's basically the key context of how we were able to go from that Jupyter Notebook environment into a fully fledged scalable service without actually losing the capabilities of providing data scientists with the full power of doing local testing, ensuring that everything works as they expect, ensuring they're able to add any extra, whether it is logging or metrics or custom insights that can be introduced, so that whenever it's passed into the sort of like production stage, it would actually be fully tested with even those relevant local tests that may be more relevant for unit tests. So with that said, today what we have been able to do, we were able to fetch a GPT-2 model. We were able to optimize it using the Onyx framework. We were able to productionize it using Tempo, first testing it in our local environment and then productionizing it in the Kubernetes scalable environment. Now, the key thing to mention is that Seldon Core is an orchestrator, so it would still use the underlying model servers like Triton. but you also support other servers like, TF serving, torch serve, etc., etc. So that's one of the benefits of leveraging some of these different toolings, and different personas would interact at this in different sort of like levels of abstraction. So with that said, to wrap up, today we were able to cover some of the data science challenges in MLOps. We were able to cover a hands-on example and use case productionizing a GPT-2 model. We were able to do this using the Tempo library to test it in Docker and in Kubernetes. And then we were able to talk about some best practices and next steps that you can take for yourself. As mentioned, you can find all of the links for this presentation in this link, as well as all of the references to the notebooks, both in the Tempo side as well as in Seldon Core. And with that, thank you everybody for joining me today on this talk, Bridging the Data Science Gap in Production Machine Learning with Tempo. Thank you all. I hope you enjoyed the talk and I hope you enjoyed the conference. So now I'll just pause there to see if there are any questions. Feel free to put them in the chat. Thank you all.
Yeah, thank you, Ali and Ju. So if you have any questions to our speaker, so you can raise your hand, or you can put your question on the chat, so we can check it out. For the participants who ask a questions, he or she will have an opportunity to get a prize from the one of our sponsor, PCCW HKT. So it will be 1 month pass, one month pass of Lao E subscriptions on some channel. So some question is coming up from Matthew and Ben. Yeah. So so the first question from Matthew, yeah, can I use Tempo with PyCharm trace instead of ONNS?
Yeah, so Matthew, thank you for your question. The answer is yes. You can actually use PyTorch directly, or you can use TensorFlow directly without using Onyx. Primarily because the servers that Tempo and Seldon Core support actually have support for PyTorch. And this is specifically the NVIDIA Triton server, which supports Torch Serve.
And the second question from Ben. Does Tempo support to create REST API in order to access the prediction?
Yeah, thank you, Ben. That's a very good question. So the answer is yes. Even though the Tempo interface is Pythonic, and what I mean is that you saw that we actually just sent a request directly using the Python function. The actual service that is running is a REST, gRPC, and Kafka supported service. So both when it's running on Docker and when it's running on Kubernetes, it actually exposes, as I just mentioned, like REST, gRPC, and Kafka endpoints, which means that you can actually just send requests directly with curl or with grp curl or with Python's request library. So the answer is yes.
So friends, so we still have 2 minutes left, so we can have 1 or 2 quick questions. Yeah. So another questions. Have you compared the performance with tools like Keeper? Is there any caching and the endpoint, or even a feedback mechanism to improve the model on the go?
Yeah, that is a great question. That is a great question. So the answer is we do have mechanisms to highly optimize the performance. And the reason why we actually are using NVIDIA Triton server is because it's highly performant. So to give you an example, we actually ran some tests recently using NVIDIA Triton on a local laptop with a GPU. And we were able to achieve with MNIST about 200,000 requests per second, right? Which is absolutely crazy. So the performance of the underlying serving options that you have with Tempo and Seldon Core are extremely, extremely not just optimized, but also optimizable. And Triton actually provides you with a perf analyzer, which allows you to identify what is the best performing configurations. On top of that, you even are able to leverage the Kubernetes-based horizontal scaling, which means that you can have multiple different sort of horizontally scalable components that you can then increase even further the performance. Of course, there's some network costs, but it is highly optimized and very widely maintained. So the answer is yes. Yeah.
So the last question is any there is low. Let me check. Okay. Yeah, the last question is any there is no need to create any Docker file in order to build the Docker image?
Yeah, that's a really good question, Ben. So interestingly enough, for the examples that we showed, you don't have to rebuild the Docker image. We actually allow you to just have to export the artifact. And for the custom pipeline, we actually leverage Conda Pack that allows you to just export the Python environment that then is loaded on the server. Having said that, we also have mechanisms that allow you to build the image once you actually want to and are comfortable to just push that to production. So you don't have to rebuild the image for the experimentation, and you also have the option to rebuild the images as required. So this is one of the big advantages of the frameworks that we use. Mm-hmm.
Okay, thank you for your presentations. So we hope that we will see you again next year.
Yeah, likewise. Always a pleasure. Always a great conference. Thank you, Sami.
Yeah. Before the end of today's conference, I have a very short announcement. So we will have a free prize winner. Okay, so the prize winner today is prize winner today are Joe Chen, Su Yi Li, and Vincent Chen. And actually, we still have one slot for today's prize winner. So we will announce at the closing sessions tomorrow. Yeah. Congratulations to the winners. So please be reminded you can ask questions again tomorrow. So you will have another chance to get the prize. So we will so the conference will be resumed tomorrow at 10 at the half past 10. So we will start with two chat. One is English chat, and another is a Cantonese chat. So we will see you tomorrow. Bye bye.